good to see a lot of students. Hope some more will join. And many are those who are joined through the live broadcast. I also thankful to them to listen me. And my topic is this advanced sensing and automation for sustainable agriculture growth and development. And before I jump into the topic, I just want to introduce that we are from a space trying to address number of application in agriculture, because agriculture is nothing for crop production. It's livestock and fisheries also a part which is very now trusty part of the government of India also. So we started from dairy to field crops. We are trying to touch each and every one and with our own capacity. And before we jump to this topic, I just want to sorry for technical glitch. We basically represent Department of Space. In this Department of Space, there are so many hands are there in which the ISRO is the main body, and ISRO represents that Indian Space Research Organization, and that also have many branches. And I am working in the Space Application Center, ISRO Hyderabad. So. Anyway, so in ISRO we have different, you can say different centers, and they have representing different field, because it's a huge activity. So one center cannot do, and we have an employee power of near about, you can say 20,000 or so. Okay, so we have different centers. Few centers in Trivandrum, few in Bangalore, few in Hyderabad. We are in Ahmedabad, few in central India. So there are many centers which are doing a lot of work in different fields. So in between, if before they solve this technical glitch, I will convey you that we are not only ISRO has an image that they are only building that rocketry and satellites. That is a part, but we are the people who used to define that for which type of application, which type of sensors are required, and for which type of sensor, what type of bandwidth you have to use, whether you are going to use optical data, whether you're going for microwave data, thermal data, and what should be the bandwidth, what is the center bandwidth, and what should be a spatial resolution, and what should be the time of pass is there. So these all need a lot of background investigation, or you can scientific investigation to do so. Oh, it's fine. Okay, anyway. So this is just a glimpses of there is some technical glitch. I just want to showcase one how the satellites will move in polar and geostationary orbits, and within 3 hours you can complete a globe with polar satellites. And if you have only rainfall dedicated satellite, it will cover 3 hours because that video is not working, so I cannot show you. But using this only rainfall based satellites, you can generate that whole globe rainfall image also. So again, video is not working, I think. So it's, I don't know. So anyway, so this is a pattern of rainfall over January, and you can see that in globe how it's varying, because we have I have put it from January to December, and you can see that how from January to December in whole globe rainfall variation is coming. So that is a synoptic view of rainfall using the fusion of all satellite data which is available for rainfall. So at the introductory is that Department of Space have a number of centers in ISRO, and we have SAT. ISAT is URSAT now, is dealing with the satellite integration. SAT have a main responsibility of payload as well as application. VSSC is Vikram Sarabhai. It will take care of the rocketry part. LPSC is take care of propulsion part. SGSC Shah is for launching, and LSC is for operational work. So another center is complementing us for providing the infrastructure, for example, satellite tracking, satellite monitoring, and LEOS is big dedicated center in Bangalore for generating the optical sensor lenses. And in this way, it's a diagrammatical picture how the different centers are working. You are set satellites, we are making payloads, launching, and then application. And so huge manpower in the form of engineers, scientists, every dimension of your field, from agriculture to geologists to you can say oceanology, atmospheric scientists, everyone is working in this Earth observation program. And here we are in Ahmedabad, located in the prime location, the heart of the city. And we are centers 1967 since, and later on we have many more centers. When we have Delhi Earth Station. So Delhi Earth Station is no historical relevance, because when we do not have a Doordarshan and all, then at the time Prime Minister of India used the Delhi Earth Station for broadcasting their messages to nation through Delhi Earth Station only. Then we have a Teku. We have Deku, then we have a Bhopal campus, and many more. So major activities what we are doing, we in SAT, not only in SAT what we are doing, we are developing. I think so. Next speaker will have some easy go. So I'm audible. Yes. So we have communication, the transponder. We are developing navigation. In morning session, I told about that navigation is now a very important part. So we have a NAHEP program in which we are providing dedicated satellites for this navigation. Then we have Earth observation, and the observation is mainly divided in two main: optical, microwave, and planetary missions, because planetary needs some different definition for the center. And we have a host of applications starting from agriculture to meteorology to village resources and for disasters. And same time, we are giving a lot of training to manpower, not in India and abroad. So SAT have an opportunity to have a UN center, United Nations Center, and we are conducting 3 important courses for satellite communication, satellite meteorology, and satellite navigation. So not from India, apart from other part of the globe, different students in the form of near about 60-70 every year used to come to our center and get trained in the field of these 3. So in the past we have launched so many satellites. We started in Bhaskara in 1979, And we are then I told in morning 1988 we had launched first remote sensing satellite IRS. And now things are improving because at that time we are in a premature state. We are learning phase. Then we have come with the very good satellite, which is called ResourceSat 1 satellite 2003. And you people will learn that in 2003 when we launched ResourceSat 3, ResourceSat satellite IRS-36, that data has been dedicatedly used not only for India, all over the globe. So we have earned huge money by selling this data, not only for US people, NASA people have used a lot of this data, and as well as European also. Then we have a dedicated satellite for meteorology, because meteorology is a very dynamic process. What temperature you have in afternoon, in evening you have very different temperature. So you need geostationary satellite. So that will capture the data in the half hour. Whereas polar satellite used to capture data after a gap of 3 or 4 days or 5 days, 6 days, something like that. So another advantage of new sensor is that we have some hyperspectral sensing also. Basically, why we are doing all this thing? Because we want to do good measurements, because we cannot do measure temperature everywhere. In a layman language, we want to monitor the crops, we monitor the resources, we do the modeling, we do the planning and decision making. So better management. So because of the data mining, more data need to be, so we need satellite data. And you will amaze that in weather forecasting, initially only 10 or 5% satellite data is used for weather forecasting. And you people have realized that weather forecasting has improved a lot in the last 1 decade. Because of that, the satellite data, what is going in the weather forecasting model is enhancing from 30-40% to 90-95%. So that's why your weather forecasting nowadays is quite good as compared to the past. So now the recent EO missions, what we have launched is in the form of CAAST. CAAST will have a very good resolution, and I think I don't want to tell you, but you have heard in the news also when India done some work in Pakistan, so they use this data, and Indian mini satellites also. So this type of images you get from CAAST. So this is our SAT campus. On the left hand side and the right hand side, we have one image from Australia. So basically, in this type of sensor, you can able to locate anything, whatever you want, but with the precondition that you have a cloud-free data. Okay. So we have another sensor like OceanSat is dedicated for ocean, and with a series of satellites are there. They also provide the data over Earth with limited capability. Then we have a dedicated satellite for weather forecasting, or you can say weather monitoring in the form of INSET series as well as megatropics. And then I'm deliberately putting the megatropic because megatropic is a satellite which is built by Indian and French people combined. So this is a joint venture between ISRO as well as the French Space Agency, and that have a capability to provide a profile washer also. And that is very helpful during the cyclone and cyclone warning. And then we have a radar imaging system. A radar, those who are a layman, radar, in morning I also tell that is a capability that you want to penetrate under the cloud. In optical and thermal, you do not get a data in cloudy or foggy season. But in the case of cloud, you will get microwave cloud, then you can penetrate and get the data. Then we have airborne sensors. In the case of disaster, we alert our flights, they do the monitoring. Many times when the flood happen in India, we do put our sensor in the flight, install the sensor, take the data analysis and give to the required user for the future work. This is just for your knowledge. We have also developed, SAC has developed this Chandrayaan sensors, and we get the data, and with the help of this, especially with the NASA payload, we able to get to know that how water molecules are available in Chandrayaan. So this is just an example of Chandrayaan images. Now coming to the topic, we are started our journey basically in agriculture for this crop area estimation forecasting. But later on, we have added so many dimensions, and now the main emphasis is agrometeorology. Because when we say agrometeorology, because crop is very dynamic, and crop is governed by weather. And when you say agrometeorology, it covers plant physiology also and meteorology also. So now emphasis is on agrometeorology in the form of drought, in the form of, you can say,
irrigation, anything, we are now focusing on agrometeorology using this. And why? The reason is that if you see the latest Government of India's financial survey report, economic survey report, you find that in India, there is a huge crisis of water happened. In your area, there, but you see, especially in this area, Punjab, Rajasthan, Western UP, Haryana, these are the where the baseline water stress is very high. And if you see the groundwater taken by the people, so you see this blue. So they are harnessing more than 100%. Even though in your case also in your region is near about 40 to 70%. So this is an alarming situation. So that's why whenever I talk about agriculture, I talk about that water is going to play a very key role, because in the present scenario, hello.
Okay. So one more technical glitch. So we here the groundwater is going to be very problematic, and water use efficiency is another problem, because morning I told you that in India, as compared to Western and China, we are near about less than fourfold of water use efficiency for crop. So we are getting more crop. For example, in the last 10 years, there is 20-25% growth in agriculture. But thing is that the water is also depleting like anything. So you have to be very cautious when you're dealing with enhancing the crop production in India. In fact, using by taking the view of every parcel of the people who are working in agriculture and allied sector, we have founded a big umbrella program in the form of SOFLOM, which means Space Technology Relation for Food Security, Agriculture Assessment and Monitoring, and in which we have dedicatedly divided the things. And for what scale, what people want to know from us. For example, production and forecasting. For a particular crop, people need district to state scale, and this information is won by the people of ministries. Whereas crop insurance, we need a scale of village to block. I categorically write that why scale, because as the scale will change, your satellite resolution is going to be changed. Then, example, an AgroMap product, we need a block to district scale, and your user are Ministry of Earth Sciences and Ministry of Agriculture and Farmers Welfare. And command area, you need command and catchment area level data. For precision agriculture, you need farm level. And from agro, for climatic change and all, you need region to coordinate scale, which speak to IPCC and MOES. So, starting from this crop production, we are now generating near about 25 crop area and production forecast. And these important issues is that you have to give the forecast before the crop going to be harvested in real time. So, for example, wheat crop, which is the year of 120 to 150 days, we are providing the forecast 3 times to the Ministry of Agriculture using your methodology. Similarly for rice also, but in the case of sugarcane, 2 times, whereas in the case of jute, only 1 time. So the pressure is from that you have to enhance the number of frequency of forecast also and little early also. So according to that, you have to change your methodology, change the methodology also, algorithm also. And recently, we are now doing the fusion of different satellite data, for example, List3, Sentinel, and all, to generate the crop area. This is just an example of a particular area in Rajasthan where the castor crop is growing, and how you can distinguish if you use the temporal data starting from sowing to harvest, how differentiation came in the satellite. This is just a simple example. So just using that methodology, how you can generate the crop area of a particular crop. So according to the crop, the season, plant physiology is economic practice. We choose the satellite data. we see how much we have to take the data. For example, a crop is 150 days, and we try to take the data for 6-7 times from the satellites to distinguish between different crops. And according to crop, we change the methodology also. For example, multi-temporal isodata clustering through the machine learning also. So according to crop and everything, we change things, and we will deliver these all methodologies developed 4-5 year testing and hand over to the Ministry of Agriculture. IS Institute is National Crop Forecast Center in New Delhi. And using the radar, because in the case of Kharif, there is a lot of cloudiness, and therefore system cloud is there, so you have to use a radar backscatter. And if you have more backscatter, that means water is there. If the less backscatter is there, then that means there is some, you can say, crop is there. So according to the using the backscatter in different polarization, if you see, you able to distinguish the crop type also. For you, it's a little bit, you can say, vague. But if you use the data, because I am showing this data because now the satellite data is free of cost available, and you can use the free software like GIS to do the work on your region. That is not a big task. I'm just advocating that which type of data you use for this season. In horticulture crops, because horticulture crops more or less you can say permanent type of feature because you have orchards and all. So we have generated the crop map for many crops under the big project of Ministry of Agriculture, Chaman. And we use the list of data from list 4 to Cartosat, and we have even used the Google image also to generate the map. And we had, for example, we have showcasing on the left hand side the mango, citrus, and banana cultivation in the Gujarat area. And we also have used this radar data also to segregate this different type of crops. And we have made some automated software to generate a number of tree count also. So, but that need a very high resolution data like Cartosat, which are some meter data. So you can generate how many trees are there in that particular location also. But here the challenge is that the new generation can take that how we can do the yield modeling of horticulture crops, because for that you need a LiDAR type of technology, and LiDAR is the thing which gives you the height of a particular object. For example, in the horticulture crop, you have a primary, secondary, and tertiary branches. But if you see optical data, it will give you the lump canopy. It will not give you the secondary and tertiary branches. So for that, you need a LiDAR type of data. So that is a new technology we are exploring. And another thing is that when you have a multiple crops in a very small area, then multi-spectra sometimes do not work very good. So what is the answer? The answer is that you have to use other than multi-spectral, use hyperspectral data. And hyperspectral data is nothing but the biochemical impression of the electromagnetic radiation. So if you get this hyperspectral data, then you're able to distinguish within a one shot or one data set, you can distinguish multiple crops. For example, I have showcases in 2 regions. One is in Bhagalpur and one is Kota. And this particular data set we have generated using the sensor, which we have is an airborne sensor, not a satellite sensor, airborne sensor of Everest NG. That is a joint venture between ISRO and NASA. So we have done near about 150 site survey using that aeroplane and taking the sensor from NASA. So NASA and ISRO team work, I think 2 years combinedly. I'm also a part of that team. So we had a lot of surveys and done good lot of work to understand that how we can do, for example, within a mango, can we distinguish the mango variety also? Yes, we can do using the hyperspectral data. So take away message is that with the help of hyperspectral data, when we have a lot of bands, you on the basis of the biochemical properties, you can distinguish the crop type. Within a crop type, you can distinguish the crop variety also. And crop yield modeling is another important aspect of this remote sensing, and we are using different approaches on the basis of type of the crop. For example, for wheat crop, we are using the crop fusion of satellite data with you can say crop simulation model. Whereas another crop, like example cotton crop, we are using the energy efficiency based approach, where we are using the FFR and light use efficiency modeling to generate the crop yield. Whereas in the case of cane yield, sugar cane yield, we are using the water use efficiency approach to generate it. Because cane yield is dependent upon the whole year crop data because cane is annual crop. So you need lot of satellite passes. So according to the crop type, your modeling technique will change. One type of model cannot be applied in a one type of same type of crop. So that is the thing. And same time, we also generating in the Rabi Kharif season when the cloud is there, using the spectrometer data, which is a quite coarse data, generating the India level crop area for the rice crop only. So we in this spectrometer advantage is that is pick rice very well, but other crop it will fail. So dedicatedly we use this satellite only for rice. And another important aspect we are now tackling with that space technology for crop insurance, which is called Pradhan Mantri Fasal Bima Yojana. Because in this, when you give the insurance to the farmers, you have to do survey, you have to do crop cutting, and the basis I have, you have to generate the optimum yield of a particular area. So on the basis of satellite data, we generate where you have to do the crop cutting experiment. Because in a one particular block or village, you have thousands of points where you have to do crop cutting for the to satisfy the farmer to generate the data. But using the remote sensing data, we have narrowed down the numbers, and we are also trying to give the optimum crop yield also. So deviation from the crop yield will give fix that whether farmer will get the benefit or not. If the case in the case of crop will be failed. Another aspect we are dealing with is crop damage assessment, whether in the form of abiotic stress, like for example, hailstorm, or biotic stress, for example, heat blast. So we are generating using the ground data as well as the satellite data, and in this, for example, abiotic stresses, we also use the sensor from the weather satellites to generate the affected area. And similarly for this any type of disease, because disease is something when you see any type of satellite data, it gives you some anomalies of disease happen. But thing is that whether that disease is anomalies coming only because of disease or nutrient deficiency or water deficiency, that for that you need some ground data, and we have developed some methodology that if you use the hyperspectral ground-based hyperspectral data fused with the satellite data, you able to distinguish the crop disease area. So we have done this work in West Bengal, in Murshidabad, and we have detected that near about 95% of the wheat area was affected because of the wheat blast area. So this type of information in a synoptic way in a very short time will be available, and you can generate at your platforms. We are generating agromet parameters, and you will be glad to hear that your university also getting this parameter regularly twice a week, Tuesday and Thursday. Every week we are providing this data, and at present, because this is the dedicated effort by ISRO and IMD, we started the work in 2012. Then we have come up to this stage to that we able to provide few of the agromet parameters to the user community. I'm not going to detail, but this is the important thing what we are providing here, that we have dedicatedly developed one portal and link, and which we have provided to the user community, and we are providing that insert-based potential autotranspiration, ADT, maximum minimum land surface temperature. When I say land surface temperature, that means the canopy and you can say soil temperature, and we are providing NDVI, predicted NDVI also as soil moisture. So everywhere we are providing, and now we have selected your center to do some socio-economic impact analysis also, whether that is able to help or not. Because in the past, you will think that what will help, because in the past, an agro advisor is giving to the farmers is only basis of the weather forecasting. So for every block, you have same type of information. But here, you on the satellite, because satellite is observation, you have a different observation for different blocks. So according to that, you can change the advisory or the block level. So whether this block needs irrigation, A block is needed irrigation, or B block is needed irrigation, you can check using the satellite data. So at present, we are providing 98 districts, 672 blocks, this data, and this is a dedicated link which user have their user and password, and they will get the data in the Excel file. They will not go into satellite email to do all the things. So we have, this is the automatization. Satellite data is coming process is done, product is generated, algorithm is run, and data is picked, put in the Excel file, given to the user. So this is the whole chain automatized is done using this particular channel. And we are now moving towards to give this type of information also to the advisories, just like disease stress information, we have developed the models. The important thing is that what we have done here, we have not used the in situ data to develop the model. We have used the weather forecast data to generate the forewarning for the disease and pest, and that we have dedicatedly done for the targeted area, targeted crop. We have not generalized for whole area, so we have a very specific model for specific areas. Similarly, we are developed crop phenological stages you can generate using the satellite data. So all software we have developed and put in our portal, which I will showcase you. And we are working on irrigation app. So we are working on the gross level irrigation app using our own products, and soon that will be given to the user community. This is the one study we have done using the 20 years evapotranspiration, and we try to showcase that how the water harnessing is increasing in India in the last 20 years or so. So you can see in agriculture, the water usage is very, very high as compared to what is used by the forest and grassland. As it increasing, especially in the Indo-Gangetic plain and central India and Bihar. I will not go into detail, and we also using this agro advisory for dairy, sugar, in sugarcane, because this is dedicatedly work done for the industry. And for the dairy, we have developed algorithm to assess the fodder. And 4 or 5 years after doing all work, we have dedicatedly given to the Amul. And now in Amul, we have a remote sensing lab. They used to do regularly area, they check in the nearby area how much fodder is available, and that according to that, we will check how much milk is going to become. But now their demand is that they want the fodder nutritional value also. So we are working on that. So I'm not going to detail because this is out of the way. Now, important thing is that now in morning also, and your automatization is that we have to be very precise. So we are working on precision agriculture. We have to check which we need in nutrient, which we do not need nutrient. So according to that, using the every airborne data, we have developed some algorithm to check the stress. So this is one of the example that in particular crop area at its resolution is near about 5 meters. So you can check in which field you have to go for a nutrient application or not. And this is another application. You can see where we can check the nitrogen application using the hyperspectral data. So that information field-wise you can check using the hyperspectral data. Similarly, you can check the salinity of the soil also. So that is the power of hyperspectral. So if you have hyperspectral sensing, that will open a new avenues for assessing that without any going to the lab, you will get to know the crop condition as well. Again, these are some new things where we are targeting using crop disease inspection using hyperspectral data. And same time, those who are working in plant physiology, that is very important to get to know about the photosynthetic efficiency. So we have some ground-based sensing instruments through which we can sense the fluorescence, and we are trying to get to know on the basis of fluorescence and photosynthetic efficiency whether the stress is there or not. So this is a new evidence which we are venturing, and this is a new area of research in these days to people get to know about the crop stress, because whether the crop stress is there is going to be affect the plant photosynthesis efficiency. And there is some drone-based activity we do, and we not only collect this picture from the drone, we use to collect the multispectral, hyperspectral, thermal data. And on the basis of that is one example we are showcasing that using the thermal data, we can generate a water requirement of a crop at 5 centimeters. And you can see on the right hand side, there is a soil evaporation and the canopy water transpiration. So we have developed a model which can segregate evapotranspiration into two, evaporation and transpiration. And on the basis of canopy transpiration, you get to know where the stress is there, and according to that, you can put the model. So this is the new thing. Another thing we have recently done UAV survey, and we have generated the algorithm to generate the leaf area index. So you can see if you that within a field how much difference is coming for the leaf area index. So gradually we are moving using the drone technology, but drone technology using hyperspectral and multispectral thermal data to generate the field scale water requirement, field scale nutrient requirement we are generating. So only taking picture will not help you. You have to work on the algorithm to generate different crop, biophysical, biochemical, and process-based parameters to address the issue. This is another system which we have installed in the form of methane sensing and carbon dioxide and water sensing. Basically, it gives you flux. And these sites we have developed across India. We at present we have 4 sites where when we develop the model for evapotranspiration or evaporation or transpiration, we used to validate using these data. We recently installed this one sensor called methane flux system also. So in future, we are trying to address methane flux using the rice system also. This is just for your information. We have developed land degradation map also, and for that you can go and use our geo portal to know about the desertification status of your state. So that is available in portal. This is just example of another district. And this is our dedicated Vedas portal. You can write down the site name is vedassite.gov.in, in which host of data is available. Now I'm showcasing only the data, what is available, and you can use as a student, you can use and explore the data. We have a vegetation dynamics using different satellite data. Everyday data is available. We have 20 years data. You just pick the data, that will give you the vegetation dynamics for 20 years. You do computation also. There's no need to download the data. No need very high-end computer. On the website only you do computation and you can save the result in the tabular form. We also using 20 years data, we're predicting the NDA also a particular location. Similarly, you just do a lot of calculation also. So cloud computing is available using this type of data set, and you do the crop classification also using this. So not only data, number of satellite data is available in our site. You do by your own analysis on these sites. And example, soil moisture is available, daily potential evapotranspiration is available, solar energy is available, and solar calculator app is available. If you got to know whether you have to plant a solar panel in your area or not, you can download our solar calculator using Vedas portal and get to know the potential of solar energy in your area. So it will geolocate your area where your mobile app is there, and it gives you the solar energy. And now, if you have recently heard, the Prime Minister of India also in the climate change meeting has talked about the solar calculator, and on the basis of this, we have developed a solar calculator for the African countries also. And we also providing wind energy, rainfall, air pollution, how much air pollution is there in the form of AOD, dryness index. So these are the different data sets available. Core data set, product data set, all are available through Vedas portal, and we are providing different apps you can download. Vedas app, solar calculator, wind calculator, anything if you want to go to from the ground floor. So we have a mobile data collection. The app is also available. So you can use if you want to use. Then we have another portal which is called MOSDET, which all provide a better data, not only to Indian community, to the global community. And if you're glad to hear that our scatometer data is used by the worldwide people all over the globe. So we have number of data set available, not only from the satellite, on the ground also. So mainly we have ground data. So these are some products of satellites in the form of meteorological parameters available. And this is the site. If you want to visit, you find number of products. And recently we have one in ISRO IMD project name is MMDRPS. This is called Multi-Mission Data Processing System. In that project, we have given more than 100 products to IMD. That means we have put the antenna there in IMD. We have put the data processing chain, huge computers, huge machines, and they do the all processing, all algorithm, and data will be generated on their site, on their user community channels. So that all things have given by the ISRO to Indian Meteorological Department. That's why their forecasting is improving, especially in the case of cyclone. So we have our own cyclone-based warning system, which is called as Scorpio. If you go, you can see when you have faced this type of problem, you can monitor your cyclone using our MOSNET portal. And you can go for monsoon is coming, so you can use our channel to get to know about the monsoon progress, how much rainfall distributed. So this is there. And presently, we are working on block to district scale. I am not using the word automation because everything is automated already. Satellite data is coming, going to the antenna, chain is there, process is there, and coming to the user portal. So there is no manual interference is there. So at present, we are working from block to district level crop assessment and early warning. Then we are working on village crop insurance. And this is the last one. Our main focus is that is farm scale research reduction and using precision agriculture. In this is a core research area. Those who want to join us, they can join us because we are trying to use disease phenotyping, crop photosynthesis using hyperspectral and fluorescence for early detection of the stress. Then we are working on crop water footprinting and yield modeling. And we are also working on surface soil chemistry using hyperspectral data. And this water footprinting, a lot of efforts what we have put for evapotranspiration and all. That's why we are going to launch one mission that is called Krishna. If you see, there's a highlighted is there, Krishna mission. That is the dedicated mission for evapotranspiration, and that is a mission basically an Indo-French collaboration. So thermal channel is built by the French Space Agency, and optical channels are built by the ISRO. So it's going to be launched in 2025. And way forward that we are going to do long-term, because long-term monitoring is required if you want to come to some any conclusion for meteorological parameters or land variables. And that had to be done using the geo satellites and new sensor with the continuity of the old sensors. We are to fuse the data using the ground as well as the satellite data in our crop models, weather models, or hydrological models. And we are trying to develop something, not only that we have to measure that climate change is there, we have to develop some solution to mitigate the climate change. For example, we have done by making the solar calculator. It is just an attempt to mitigate the climate change. So more solar panels can be put in the places where we have a more solar heating. Okay. Thank you. And we are now working on, because governor is there. So one team is working on microgravity experiment also, and some radiation experiment using plants. Thank you. If you have any question, you can ask bluntly, no problem.
If any queries are there from student side, they can ask.
Time is there, so I will showcase to some videos if possible. So if it not work there, so I will try to work here.
Sir, during our board discussion, we said that we can identify the different metals to radar system.
With different?
We identify the different varieties of the
Different?
same crop to radar system.
Different variety?
Yes.
Not right.
radar system cannot do, but the hyperspectral system can do.
You need for differentiation between the varieties can be done using the hyperspectral, because hyperspectral is a sensor which can basically give you the impression of biochemistry of the particular plant. If the biochemistry is different between the one cultivar to another cultivar, you're able to find out the signal between using the hyperspectral. The hyperspectral data, if you want to understand, it is nothing but it is a modified multispectral sensor. You have a contiguous number of channels within a one multispectral channel, that is called hyperspectral. Yes. Yes.
Long-term observations of meteorological parameters. But you sensing possible for long-term?
Yes, definitely.
How very practical?
For example, we have some essential climatic variables there, like temperature is there, leaf area index is there, FFR is there, soil moisture is there. So for that, whole world is working on to generate a long-term database. So, for example, in very, you can say, I will challenge your question. If you want data for 20 years of company, for what is the status of rainfall is there for 20 years, for whole company, not a particular station where you have measured, so that you will get it. So that is not a big issue. That's why I showcased one site in Vedas, in which we put the data for demonstration. You can open the rainfall data, go to vegetation monitoring mode, open the rainfall data, click on from which year to which year you want to check the data, you will get it. That is not available. Very easy. Rainfall, potential evapotranspiration, soil moisture. So these are the parameters is now available for long term. But now challenge is that we using machine learning and artificial intelligence to predict the data also. We give the data, this is an observation that in this whole Parvani region, in every block, what is the soil moisture? And same time, what is going to be within 1 week, what is going to be happen? So predictive mode also we are trying to give you. So we started with the vegetation vigor in the form of NDVI, but in future we will give lot of more parameter in the predictive form. So that will be very used. At present we are giving forewarning. That will predictive power will give you better for decision making. Any more questions? Any student? So I will tell a student that if they are unable to understand, this is not a big deal, because for you this is little bit other type of things. But try to visit some sites of which we have developed from the ISRO geoportal. Bhuvan is one, Vedas is there, Mosaic is there. So you can get lot of data. You just go and explore like what you are exploring in YouTube. Yes.
Hello, sir. Myself, Bhusri Gopinath, DFSRDA student. Now, at present time, we require cross-person assessment. Cross are affected due to the natural climate. We require large number of force to predict. By using this precise technique, we can let the predict of the labor force. Is it possible to be more accurate than this survey?
Yeah, that is the target. We are doing so. For example, hailstorm is happening in Nashik a few days ago. But hailstorm forecasting is itself is a very tough game. So that will come in the meteorology umbrella. But at present, we are trying to able to distinguish whether the losses occur more or not. For example, in your Parvani district. So if rainfall is happening in one part of area is heavy, but here is a moderate, we able to distinguish. So on the basis of that, you can say the losses is happen more there and less here. Regarding that, we have to print the farmer. For example, disease and pest, we are trying hard to give a forewarning, but for lightning, there's a one issue in very that's happening in North India. Lightning warning is very important. So that is a challenge. Hailstorm is a challenge. We are working on. Our meteorological team is working on to give this type of forecast. Yes, heavy rainfall forecast we are providing.
Thank you.
Thank you, sir. Dr. Nigam, sir, he has given a very nice information and detailed information about the use of remote sensing and digital technologies in quantifying the biotic and abiotic stress. Again, he has given information on land degradation mapping, also given information about the Vedas portal, Bhuvan portal, and how the students and faculty also they can utilize this data for their future research policies. Also, he has given information about the MOSTAT portal for this weather gallery. Again, definitely, once again, I thank you, sir, and your information that is given in your speech. It will be definitely useful to faculty also and for our postgraduate students also for planning their future research work. Thank you, sir. Now, our next speaker. He is Dr. Raghu Muttugodi from scientist from the University of Maryland, USA. As an Earth system scientist, he studies the interactions between the physical world and life and explores the co-evaluation of life and climate and what it means for sustainability. His work also involves data analysis, regional Earth system modeling, and predictions that are combined to advanced processes and predictive understanding of Earth systems, especially at the regional scale. Producing region-specific predictive information at daily to seasonal time scale that is useful and usable for developing the scenarios. So please. For developing the scenarios for years to decades are his main interest. His personal interest is also include agroforestry as sustainable agriculture and watershed management approach and its ability to sequester additional carbon in the soil while enhancing the drought resilience and the soil moisture persistence. Definitely, sir, your speech will be very useful to our students. Now, may I request Dr. Pawar, sir, SN Pawar, sir, to welcome Dr. Raghu Muttugodi. The rapporteur for this session, I also request Dr. Pawar, sir, to welcome the rapporteur for this session, Dr. MP Jagtap ma'am.
Yes.
Okay, now I request Dr. Raghu Muttugodi, sir, to start his lecture.
Okay. All right. So Kandan told me that my talk would be too technical, so I'm going to be very careful. Also, I'm going to give a broad concept of where agriculture fits in the so-called human and natural system. This is what we refer to as Earth system.
And it's also a way to think about the future, because the great thing about satellite data is that it is very good tool to monitor things. And you know that the limitation is that it can at best be in near real time. If you're lucky, it will be few hours behind. If you're not, it will be few days behind. So planning even for the next few days, let alone future adaptation plans and so on, cannot be done with satellite data. So even irrigation advisories for a few days ahead and so on could be serious issues if we rely only on satellite data. So that's where these predictive models and projection models come in. So I'm going to just introduce you to the concept of how the Earth system can be thought of at a global scale and then at a local scale. So I have a very complicated definition, formal definition of system here, but it's much easier to just think of your own body as a system. We have a skeletal system, we have a circulation system, we have a digestive system, endocrine system, and so on. So system is made up of a few components. Each component by itself may not be fully functional, but when they work together, they produce something that each component cannot produce. So Earth system in that sense is what we are always worried about. This came out of a meeting in the 1980s in European Union called the Brotherton diagram. I won't go into the details, but basically it's showing the physical climate system here, the biogeochemical system here. And there are lots of things in the middle, and there is forcing from the sun and volcanoes from here, which are referred to as external forcing. Anything that disturbs or perturbs the radiation balance at the top of the atmosphere will be known as external forcing. And the main thing about Earth system is that there are lots of feedbacks within. So even though sun may only have a forcing at daily retail, which allows us to also predict beyond one season. Change and expectation change. We should know that. Farmers should know that. So it's not just giving more precise information for farmers now, but it's also preparing the globally farmers, the country, the state, and in fact, the entire food security market in the region for what may be happening half the recording is lost. Should I start again? So there are some rich counties, when they do development, they want to know how that development will affect the Chesapeake Bay. Okay, so they wanted. So we give them a tool like this. They can pick any region. They can pick time scales. They can pick what variable they are interested in, and they can change based on their growth projections and so on. How population will change, how travel miles will change, how the prognosis is for businesses in the region, renewable energy, land use, and so on and so forth. So the video of this outcome is there. I will show it there's a chance. Am I on the internet here? Oops, okay, I'll come back to it at the end. Let me just give a brief context for agriculture now in the Earth system. If you look at the global emissions, India looks very similar. Since it's, are they getting it also? No. So the video is just a demo which shows with say what did you say?
It's running here.
You're playing that? Oh,
No, it's the same. This finish area.
okay, it's done. So, we'll put the
Want the link inside this?
Yamcha, screen share.
oh,
Okay.
no movie. So I just want to give a quick context for agriculture, so you can. Where is the share? Okay. So this is global, but the India version looks very similar. Obviously, energy takes up most of the carbon dioxide emissions. There is agriculture. Of course, agriculture also uses a lot of energy, but transportation and buildings dominate in the mid-latitude countries. If you look at per capita greenhouse in the US in 2018, you can, I don't know if you can see way back where, but electricity and heat take up most of the emissions portfolio. Transport is on the second, and for them, food is agriculture is here on the fifth position. We can look at the same thing for India. So you can see that electricity and heat is still large for us. The numbers are different, of course. Manufacturing and construction takes a lot here, and our agriculture is not even here. Okay, so the relative amount in with which we emit to the atmosphere depends on how rich we are. And the problem is, if you look at India's per capita emission, average is only 3 tons per year, but actually the rich people will be emitting something like 16 tons per year. Poor people will be emitting less than 1 ton per year. So the average is kind of different. But if you look at the sectoral emissions by the world, you can see that the agriculture here has remained almost flat. Electricity and heat have gone up, transport has gone up, manufacturing and construction has gone up. And for India, it's somewhat similar. Agriculture has gone up a little, electricity and heat have gone up a lot, manufacturing and construction have gone up a lot. So this tells you that agriculture can not only be problem, part of the climate change problem, but actually it can be part of the solution. If we can find ways to put additional carbon into the soil with practices like agroforestry or low tillage and no tillage practices, then you can actually make agriculture very much a part of the solution, where you are increasing soil carbon which has already been lost. When you lose soil carbon, soil structure is gone, nutrient retention ability is gone, its water holding capacity is gone, but you can put it all back. Okay. So obviously in India, methane emissions by agriculture is quite high because of rice paddies, and of course we have livestock issues as well. So I won't share more of this data. I'll just jump to saying how we rank in terms of 6 economies whose food systems produce the most emissions. So even though our per capita emission is not high, our food systems produce quite a bit. So China is the top there, Indonesia, US is in the 3rd position, and India is in the 5th position. So at least in this sense, our agriculture has to become more greenhouse gas friendly. We have to reduce agricultural emissions. So there is all this precision agriculture and so on and so forth. But ultimately, we want to also make agriculture part of the solution. And of course, India is now wasting more. This is globally 6% of global greenhouse gas emissions come from food waste. And that's not good, right? Even a country like India, as people get richer, they eat out more, and restaurants waste much more food than you would waste at home. So our food waste is going up year by year, and this is really not good. There is the drivers of greenhouse gas emissions from agriculture. Population increase is always the main cause so far, but the good news is that both China and India, the fertility rates have dropped over the last several decades, and population will drop because as we educate women, they have fewer kids. Doesn't mean consumption will go down, but at least population will go down. And there are the calorie consumption goes up, and
my name is missing from attendance sheet.
And so on and so forth. Okay, some sound is coming. So let me come to directly to the ideas of what we need to do in terms of production, consumption, and subsistence farming. This is one of the cartoons from a FAO report. So you're looking at global food chain and local production systems. So you have production here, storage and processing, distribution, retail and markets, and consumption. And there is obviously dependence between the two. So direct link between production and consumption in subsistence farming can reduce the greenhouse gases, energy consumption, but also increase income for the farmers. At the global level, there is retail and markets which affect demands, crop selections, productions like cash crops, sugarcane, cotton, and so on and so on. So there is also a link between global markets and consumption, where consumer influence tend to be limited over productions. So they are tend to be driven by market forces. Maybe bioenergy, corn production will drive up corn prices for some, or using grains for animal feed often affects food prices for the poor, and so on and so forth. So I'm saying that agriculture, as we learn here, doesn't have to be limited just to worrying about soils, water, irrigation, precision agriculture. We have to put it in the context of climate change, market force, and so on and so forth. So if you want to think about mitigation, adaptation, and co-benefits of food system responses, you can think of food system responses, mitigation, adaptation, and co-benefits. Here, I won't go into all the details, but increased soil organic matter content, I read here, change in crop variety, improved water management, adjustment of planting dates, precision fertilizer management. So these are all either just mitigation or mitigation and adaptation. And all of them have core benefits ranging from livelihoods, biodiversity, water conservation, pollution reduction, and so on and so forth. So these are also very critical when we think about agriculture as part of the earth system and this nexus. So food and water are very intimately tied together. Food production always affects water consumption a lot. So irrigation advisory, smart agriculture, precision agriculture must reduce water use. Plus, they also are going to play larger and larger role in bioenergy. So food, water, and energy. And foodborne diseases in India. India is still the largest infant mortality from diarrheal diseases. We are worse than Pakistan, Nepal, and Bangladesh. This is a shame. Why? Because there is issues of hygiene, of course, and food issues as well. So foodborne diseases, food security, food nutrition, and food safety are big problems as well. There are other methods of silvopasture and livestock breeds and so on and so forth that I won't go into. I'll stop so that I won't need independence time, but you get the idea. What do we do in terms of monsoon and the food production itself? I won't go into the details. I have a paper coming out in some physics newsletter soon you can read. But the Indian monsoon is now become very extreme. In Parvani region, CAAST tells me that there's not a trend, but the rainfall onset and withdrawal have changed. So the length of the rainy season has changed, and the amount of rainfall distribution is in a way that we get heavy rainfalls. Crop calendar has to be changed, and it can be an issue of crop damage. For example, if it rains at the wrong time for soybean or onions or whatever else, it can be a big issue. So we need to worry about how the rainfall is changing and how it will change in the future. Unfortunately, Indian Ocean is being affected by the Pacific, by the Southern Ocean, by the Atlantic Ocean, and by the Arctic Ocean. There are nice papers coming out of NCPR and employees and so on these particular fields. So in that context, if you think about the trends, as I was saying, companies were somewhere here. So these are the interannual variability of rainfall or homogeneous regions of Indian summer monsoon for different decades. So this is 1901 to 1930, 1931 to 1960, and so on. So as I was telling Kailash offline, how is it possible dynamically to produce such small scale long-term variability? Okay, this is a very difficult question. And of course, India has invested more than 500 crores since 2009 in buying big computers and hiring people to improve the forecast that I mentioned at short and medium term and sub-seasonal time scale and seasonal to interannual time scale. And India, for the first time, has also participated in the IPCC projections from IITM, CCCR, and our projections are really good compared to all other models as well. So how can we use these improved models to understand how the trends will change in February, what that will lead for crop selections and crop calendars and so on and so forth. One good thing is that no matter what forcing is happening, whether it's El Nino and La Nina, or whether it's the Arctic ice, whether it's global warming, or whether it's the Atlantic, they always project onto the active break cycles. I hope some of you have seen this figure. You are basically showing the climatology of rain from June to September, and the blue above is where we have active period, which means we have few weeks of rain. Red is where you have few weeks of break period. So either break periods are getting longer and more frequent, or the active periods are getting shorter and more intense. In other words, this seems to be the most fundamental intrinsic time scale for the monsoon. So if we put our energy into improving this sub-seasonal forecast, we will make always a big contribution to farming and agriculture. Okay, so at the international level, there is under the World Climate Research Program, there's a project called S2S, sub-seasonal to seasonal forecast and applications. And actually, Kailash and his advisory is basically doing exactly that. but they have to now officially become a part of this project. And any papers you have ready have a special issue coming up on applications or SQS. You will fit very well there, so you should submit and give you the information. The idea here is, of course, the so-called ready, set, go framework, where we take seasonal forecast. So if in May, IMD says this monsoon is going to be normal, above normal, below normal. Last winter was La Nina, so I expect that this monsoon to be below normal. Then how do you plan the season? Then you get sub-seasonal forecast, 10 to 45 days. Then you know the onset date, and you know when the sowing date will be. So if you are going to choose moon, it may be a problem. What is the other problem you choose in the beginning? Yeah, so these kind of detailed selections can happen based on these kind of forecasts. And the short 1 to 3 days, medium 3 to 10 days can then give you better irrigation advisories and monitoring crop stress and so on and so forth. Okay, so we have done this kind of thing in the Chesapeake Bay with a very detailed model. I won't go into the details, but I will just show the global Earth system model will give you boundary conditions. You will run a high resolution regional Earth system model, which does crop models. So CAAST runs DSST. This model combines DSST and GOSAT. You can go and see this on the website. So you can take the model, you can make projections, and you can solve all kinds of problems, whether it's human health, agricultural adaptation, future planning, and so on and so forth. Okay, so there are other details here on the AI that I won't go, but there is something called responsible research and innovation, AI, that is becoming more and more mentioned as a solution for everything, is right now not doing things that are as benign as you think you are. So there are details when you apply AI to agriculture. What are the things you have to worry about? Anticipation, like unintended consequences, reflexivity, so response to rural issues and so on, and inclusion, including subsistence farmers versus industrial farmers and so on, and responsiveness. When disasters happen, extreme droughts happen, extreme floods happen, extreme events happen, how does your AI system respond to produce appropriate information? So those are the kind of details one has to worry about. From pretty close to 4 p.m. So I'm going to leave a few minutes if there are any questions. It was a very broad conceptual talk, so there is not much technical details, although Fernand will tell you that it was too technical. But if something got through, then you can ask me questions. Nothing got through.
If any questions are there from students and faculty, they can ask. Okay. Thank you. Dr. Raghu Murtugodi, sir. Dr. Raghu has focused on very important aspects regarding these global warming, impacts of global warming, and the adaptations and mitigation strategies regarding it. He has also focused on the carbon sequestration, assumption, the information regarding the ocean forecast. And one other important point mentioned by Dr. Raghu is about 6% greenhouse gas emissions. It is from the food waste. Obviously, it is not good. So definitely, his lecture was very useful. Thank you, sir. This lecture will be useful to the student as well as faculty. Now, for the further session, I request Dr. Meenakshi Patel. Okay, I request.
Thank you very much, Ravi. Good afternoon, all of you. For session, we are quite fortunate that we got the speaker, Dr. Pinam Chinnaswamy, and reporters, Dr. Madam. So may I request both the guests, please occupy the seats, please. For presentation of Dr. Chinnaswamy, I would like to give some small information about Dr. Chinnaswamy. So Professor Chinnaswamy has experiences teaching undergraduate at Westland University, USA, and during his master's and PhD from the University of Missouri, USA. After getting research and teaching experiences in USA, he moved towards the Asia to contribute to important large-scale research projects with World Bank, IDB, and ICIAR funds. He has led projects funded by World Bank, ICIAR, and ADB, and local government funds in India, Sri Lanka, and Nepal. In particular, he has 8 years experience in field of experience in field hydrology and modeling, and hence can adopt a model to suit the microclimatic varieties that occurs at the site scale. Over the past year, he has had fruitful collaborations with many professors, scientists, and water policy makers, and he is confident that he can bring his experiences in high quality research, teaching, and diversity to any reputed organization. He always felt that he was part of the academia, and he continued to teach modeling practices for water managers in workshops in India, Nepal, and Singapore. He is currently working as assistant professor with Indian Institute of Technology, Bombay. He is again associated with the Center for Technology Alternatives for Rural Areas departments, with focuses on enhancing sustainability in water, energy, and food for rural regions. His specialization on the groundwater issue in India, where the groundwater extraction is highest in the world. So his area of specializations are. So before his topic on his presentation, I would like to invite Dr. Asema sir to welcome the today's speaker. I would like to invite the Agarkar sir to welcome the today's speaker, Dr. Pinam Chinnaswamy sir. And may I request Dr. Papita Gorkhade madam to welcome the Godavari Pawarkar. Now I request Dr. Papita Gorkhade madam to welcome Dr. Sunita Pawar madam, who is the speaker for this section, first session. So I am requesting you all please occupy the front seats.
So student, please come fill the
Come forward, please.
blank seats here. Don't sit backside, please.
Now I request Dr. Chinnaswamy to give the lecture on the opportunities for digital technologies and collaborations. Dr. Chinnaswamy, please.
So this first year, second year, MSc and PhD. MSc PhD.
Good afternoon, everyone. Thank you for having me and thank you for the lovely introduction. So my topic for today is Indian Agriculture 4.0, opportunities for digital technologies and collaborations. So all of you are mostly, I asked you guys are MTech or PhD students, MSc students in agriculture. So you'll be interested in what is Agriculture 4.0. I'll go through that in the next slide. Okay. So my outline for today is I'll explain about climate change impacts, very less because I think two of the previous speakers gave a very good introduction about climate change, right? But I'll just go into a little bit why you need Agriculture 4.0, why you need sensors, and how you can collect data better. Okay, for that I'll give my spiel of climate change, need for better data management and data collection using Agriculture 4.0 techniques, data access and database management. So basically, how do you collect all this data, put it in a nice folder in your computer, then upload it onto the folder servers, cloud servers, etc. Okay. Automation and digital monitoring, which is part of Agriculture 4.0. And how do you get into collaborations with industry and government? The final topic for today would be discussing about the entrepreneurial startup, those kind of aspects for agricultural people in data science. Example, I'll give you how to make maps and sell it. A big company is MapMy India, which is $1 billion company in India which makes maps. In fact, they make maps for ISRO also. I'll show you the slide how they make maps. Okay, and then we also have GIS and satellite solutions. So please understand and stop me if you have any questions in between. Because all will not be in the field working with farmers. The other aspect of working with farmers is by this, you have good data sets, you give them advisories and good database management, which is kind of part of this Agriculture 4.0, where you see in FAO's book, all of these data collection things are happening, right? You have a drone, you have a survey being taken by some farmers, you have your automated tools, your tractors giving signals, etc., etc. So it's not only to automate and operate them, but indirectly there's data also collected. Okay, it's like your smartphone. How many of you don't have smartphone? No one, right? So everyone has a smartphone. And when you search for a Google, and then you, without notice, you will see, like, for example, I'm searching for Chinese food. 2 days later, I'll get an email saying you have a coupon for Chinese food in my Gmail, right? Why does that happen? Because kind of your search is being sold to companies. Similarly, you could have your instruments which are basically there to drive into the field, your tractors, for example. But how do you generate data out of them is a question. For climate advisories, all these planes that you see would be collecting weather data from Boeing and other aircrafts. Technically, they should pay all the passengers, but they don't. Can I admit her? Kailash, someone is waiting though. Can I admit?
Yes, please.
Okay, so indirectly you are the data, but you don't get the money. So what I'm trying to get you here is in Agriculture 4.0, you not only make these beautiful machines, but also you become the data owner and kind of do a startup. So let's have a quick round of climate change on agriculture. Who says climate change is not happening? Anyone thinks otherwise? It's not climate change, it's just hot and cold. It switches now and then. No one? Okay, so then I'll go into this slide. Let's look at some facts. Okay, I'm recycling this from a recent climate talk we gave. So you have the increase in Indian monsoon has been predicted from 2000 to 2100, according to IPCC reports and all. Let's not worry about 2100 or 2100, right? God knows what's going to happen here, but we are more focused on this part. The next 5 years, what is going to happen? The next 10 years, what is going to happen? And for that, we don't have good data. Okay, so that is one thing. But what is this map saying is that your rain, there is going to be an increase in monsoon precipitation, and there's going to be a lot of variability. So different colors are different models, all are saying different stories, which is, but on a rise, it is rising above the average. Okay, from the average point, it is rising up. Then you have extreme rainfall increase as well as your droughtness. So that we are seeing now. Kerala every year is getting flooded. Mumbai, where I am, every year is flooded. I don't understand, right? So every year, why should a city flood? And technically, it is a 50-year flood or 100-year flood in Kerala. Chennai was bounded by flood just in November. Like 1 day, not 1 day, 7 hours, you have 200 millimeters of rainfall. Okay, so both are increasing, both your dryness or droughts and your climate extreme, which is flood. So Professor Raghu was talking about this a little bit. You know, what is actually happening is, think about your rainfall, which is spread from, you have a good bell-shaped curve, a normal distribution, okay? And your dashed line is your projected climate, and your observed data is your solid line. So what is happening is the average is shifting, okay? So your growing season, your crops have to adopt to this new trend due to climate change. It is the same rainfall amount, the same area is there in the curve, but the peak is shifted. In the next one, what you see is, what is happening? The average is lower, which means you're getting lower rainfall than usual. And in the last one, which is happening is, your peak is coming before the normal. Okay, so for a person who's doing sugarcane or groundnut, etc., they would have a particular growing calendar. But when this happens, your crop is lost. But one thing is also happening. So there's a shift in period, longer or concentrated event. This also happens. It may not be just lower rainfall, but rainfall concentrated within 1 or 2 months. And that is also bad climate change impact, because rainfall which should happen 3 months for the crop is happening in 2 months. And that is why you see a lot of farm ponds. They want to capture the rainfall, put it in a farm pond and then use it. Okay, at the earlier peak. So this is where extremes have already surpassed, which means these projections are already wrong. What they predict which should happen to 2100, we are seeing in 2022 or 2021. So all these models are wrong in this aspect. However, it is on an increasing trend, okay, or the floods and the drought occurrence. So how is this impacting agriculture? Just what you know, but I'm just reiterating so that we can come into the data aspect. Low crop productivity, yield, quality, because there is a shift in cropping calendar. A crop which should have 3 months of water is getting 2 months. Or if it gets more, your crop is drowned, right? So there's a shift in cropping calendar. That's why there's a low productivity, yield, or quality of the crop. The Kharif is using the Rabi water. Kharif is what? It is during your rainfall season, the monsoon crop. If the monsoon is not enough, what happens? You have to, the farmer goes to the groundwater and it uses it, which was used for Rabi. So your Rabi's budget is shortened. With business as usual scenarios, the advisories are failing. Okay, so IMD's advisories have been wrong for a long time for Maharashtra. So Maharashtra government is, the farmers are pulling out. Already 8 states have pulled out from the advisories and they keep their own advisories. So this is again the same point Professor Raghu was making. There's a lot of money spent on these, but no one knows how much feedback is happening. Less water for current acreage, unsustainable use, secondary water depletion, which is groundwater, is happening. And then there is low climate change adaptation. How do you have a crop that can adjust to climate change? So what you see in hybrid crops is you're trying to make a crop which can adapt. For example, if there is less water per week, it should adapt for the next week and then try to grow. It should not die, it should try to grow. and mitigation is less severe. Yes, the water is not available, but the severity should not be felt by the plant. So these are kind of hybrids that are people working on. And the last one, which is very important for climate change, is no regret scenario, which means even if you have climate change or not, for those who didn't know or did not agree with climate change, you still need water and you still need food. For that, there should be some infrastructure should be developed. Okay, so farm ponds and other things I was saying. The same data that Dr. Rahul was presenting from WRI, I'm presenting again and CGWB. So both the surface or the net water stress is increasing in India, 54%, and mostly in the northern and southern parts. And your groundwater is being depleted unsustainably, especially in the northern parts and some parts of Karnataka, Tamil Nadu, Kerala. Okay, so what are the issues in agriculture water management? What we are not understanding, what farmers or the policymakers are not understanding is there is two aspects for water management. One is supply side, where you determine how much supply you have. It could be your dam water, it could be your rainfall. Okay, so this is the supply side management, and the demand side is how you apply the water to the crops and what type of crops you grow. For example, if you have this garden outside, if I put sugarcane, I have to supply 10 times more water than millet, right? So that choice of crop is your demand side management. And there are farmers who would always grow sugarcane. In Maharashtra, it happens. But what type of sugarcane can you grow to mitigate to climate change is the question. You still want them to grow sugarcane, but can you lessen their losses? Okay, so there are two aspects for this. There is supply side and the demand side. What the reality is, there's less supply side management, less efficient supply side management, and very limited or negligible demand side management. Agriculture universities like you do work on it. If you go to the field, you see different plots, same water applied, and then the yield is estimated. So that is what you're doing. That is demand side management. However, on the ground, is it being applied? It is not. Does a farmer get extra money because he's growing millets for saving water? No. You see the point? So that's where you complain that climate change is happening, but you're promoting one side sugarcane or other crops, rice, by not supporting millets is one of the questions. I'm using just millets as a random example. It could be turmeric, it could be other crops also. Understanding of farmer attitudes, ground reality. So here's the ground reality. Even if I grow millets, will it be accepted by the people? How many of you eat millets? Can I see some hands? Millets, yes. How many times do you eat? Yes, sir. You, white shirt? A daily. Very good. You won't get sugar, sir. But yeah, I used to eat once a week, but now I have 6 times a week. And this was what traditionally we have been eating. Okay, so we shifted to the rice crop, which was kind of, let me tell you Tamil Nadu story. Like traditionally for Diwali, Pongal, all these big days, we have biryani. And that is the only time they would see rice. Other than that, it was millets, sorghum, maize, those kind of things. They were healthy, no sugar, diabetics, etc. Right? And now if you go to the doctor, they have a big bottle in front saying eat millets. Going back to your traditional food. But honestly, not only for your health, but also the health of the land, these are the crops which have been traditionally used. And it is not documented, because we didn't care about patenting, we didn't care about studying it in detail. They wrote it and they kept it in some scriptures and left it, that's it. Okay, so the policies need to be updated. And this is one of the reasons I joined the policy school. All the science just stops as papers and not applied. So you should also think about what is the current policy for sugarcane. You know, sugarcane has a lot of subsidies and money to pull them out of stress. But why is it not given to other crops? Think like that, and then you could see some budgets rearranged by the government. Okay, so climate change, because one of you guys can be an IAS officer sooner or later. So think those lines. It's not only startup. Slowly, India is moving towards people who are educated well and jumping into civil services, etc. So climate change and associated buffers. More reactive than proactive solutions are there. What is reactive? If I have a fever, I go to the doctor, I take a paracetamol. That is reactive. But knowing that I'll get a fever, I won't go out, or wearing a mask. That is proactive. Okay, so most of the decisions for crop, saving a crop, is reactive. After the flood, they go and see how can they save the crop. But while the flood is, generating or monsoon is peaking, why can't you do something and save the crop? And that is where your agriculture 4.0 is going to throw light. Your satellites are going to help you do this work. Okay, this is where there is absence of data to do this so-called proactive measurements and smart agriculture. The same as your millets. I don't have sugar, but I know if I keep on eating this rice and sugar, I'll get one day because of my family history. So I'm proactively eating millet for at least health benefits, right? So what is the biggest buffer for climate change? You've seen that climate change is occurring. Your summers are long, your floods are occurring, your dam water is not enough. Maharashtra has so many dams. In fact, one of my students is the chief building engineer. He controls 36 dams in Maharashtra. He tells me within the dam is full 100%, but within 1 month, 2 months, it's totally dry. So what people use is groundwater. Okay, water resources during floods are not enough, so they use groundwater for the Kharif season and Rabi season. Same during droughts, there's no water, people use groundwater. And because of that, this study by Mishra et al. Shows clearly that there has been a steady increase of tube wells, the green. So all the data, all the water that the farmers are using, mostly for Kharif and Rabi, is shifting towards your use of groundwater, whereas your canal and surface irrigations are coming down. Yeah, so, and that is the reason why you have all these blocks turning red, but there is a data issue on this also. What data, has anyone worked with groundwater data? In agriculture, they're talking, okay. So what wells do you have in campus? Anyone? Is it a shallow well, dug well, or is it a bore well, deep well? You see both, right? Somewhere, if you go to farm, you see a dug well, which you can see the water, and then there is a deep bore well, which you cannot. And all these maps are made by using shallow or dug wells. These are not wells which were initially used by pissometers to monitor the deep wells. Someone is talking at you. Okay, thank you. Yeah, can you hear me? Yes. So your data is not available. That is a question. Okay, so groundwater board. How many of you know how many times groundwater board monitors data? It is 4 months in a year. Yeah, someone saying 4. I don't know. 4 months in a year they monitor, but farmers have 2 crops, 3 crops. So how do you capture that water, the use of water by making these maps? You cannot, right? And they're mandatory is to only monitor. It is you who have to convert it into information. And that is where data is not available, but how do you improve on it? By using other products. So here's where I stop by saying climate change is happening. There is a water stress. You need more data, okay? And I'm going to jump into agriculture 4.0. Before we jump into agriculture 4.0, I will tell you what the sequence is. Agriculture 0 or O is your animal power, where they use horses, bullock carts to plow the field. Then slowly the industrial revolution kicked in. The steam powered tractor was there, which is agriculture 1. And agriculture, these are levels, okay? So agriculture 2 is your tractors with the IC engine. And then your agriculture 3 is a tractor which is multi-tasking. It can do harvest, it can do plowing, taking a tiller and taking the crop to the factory, all these things. So you can see how the progression is happening. And what is agriculture 4.0 is where you don't go to the field, you can make it automated. The guy can sit, he's not even in the field, but the tractor can collect data, he can go and do precision agriculture, drones, etc. So it is kind of an internet-based device or something which is relaying wirelessly and it is controlling. What has happened is, this is not only for tractors, but all agricultural products. There is a agriculture 4, agriculture 3, agriculture 2 stage. Here's where we need to leapfrog. What do you mean by leapfrogging a solution? See, Indians and most Asians were here, okay? And then they didn't get the steam-powered tractors. I have never seen one, to be honest. Okay, but so we had to wait till this tractor was so cheap, and then everyone started to use it. So part of the time, the Asian people were left out of these tractors, and especially the poor farmers, they are still here. They're not even in this stage. So we need to leapfrog, which means we need to jump from 2 to 4, not 2 to 3 and 3 to 4. Okay, and that could be possible because of your cheap, low-cost technologies that have been introduced. These are very expensive compared to these because it is more computer-based and chips which are easy to control. And this is also agreed by the FAO with this book. Those who want, please take this PDF. It is available online and read through it. There's a lot of multiple techniques they have showed how to have a sustainable system. There's one in the storage to tell, okay, the storage is full or not. How much space I have to harvest and put in the storage. What is the temperature of the storage unit to save the crop? All this is being monitored and sent to the farmer on the smart device. But again, I'm saying it is all data. You can use it for long-term analysis. Okay, so for those who didn't have the introduction about these tools, I'm going to give a small introduction. I did see this image on your NAHEP lab. So I think most of you know it, but let me just go through it. So you have ICT tools, IoT tools, IoE tools. Smart means it can take a decision or you don't need spoon feeding for it. These are the tools called smart tools. And they can be given as ICT, IoT, or IoE, where ICT involves your information communication tools. It has or internet communication tools, both have been used. You have satellites, your mobile advisories, data sharing, monitoring, all these are part of your ICT. There is some overlap, but I'll show you where it is mostly the same. And IoT or Internet of Things is precision farming, agricultural drones, livestock monitoring, smart greenhouses, etc. And IoE is Internet of Everything. Okay, connecting digitally farmers with markets globally over the internet. So whatever is on the internet, you can get connected through the IoE devices. Okay, so you could see that some of these can be here also because your drone is only doing the precision farming, and then it can also do some satellites, remote sensing, data sharing, all these things. So your monitoring can be done by agricultural drones. So there is a gray line where it can be both ICT, IoT. However, we can just keep it as if you're using extensively internet and technology, these tools can help you in agriculture 4.0. Okay, and you can see that the market is here. There's one government market, ag market of India, which tells you the prices so that the farmer can know that, oh, I can just apply some more water for 2 days. I can save my crop and then go for a better price. Or I can put it in a storage unit and then get a better price. Those things. So this is enough for IoT, but how do you make all this data come together to make a decision is the question. So that is where you have application of GIS. So for those who attended my last year class in company, I talked extensively about GIS, but not about data collection. Here, this talk is about the Agriculture 4.0, where you have IoT management tools. And these tools can be combined with GIS to have more information and data. Okay, I'll give you some examples so that you can understand where these IoTs can be used. The data collaboration is needed. You cannot always have the government backing you up with good data. Okay, in a country like India, where the average landhold size is very small, can anyone tell me what is the average land holding size of a farmer? Sorry? Here's some answers. Around 1 hectare. Is that okay? Yes. Okay. So homework for you. This for you. Please do it. Okay. So what is happening is the land size is coming small. My grandfather had 17 kids. He had half the village, but 17 kids, right? So what has happened is the land just got divided into such a small space. So when I first went to the village, I saw half the village is my grandfather. I was so happy. Hey, I'm so happy. But then 17 kids lined up, you know. So then the division happens. Each kid has three kids. So you see, nothing remains back. Your land, they don't sell it. They just divide it, right? So this is how the land holding sizes come down. And that is why your government average data is not enough. So government data is important. Why is government data important? Now I'm saying it's not capturing it properly. But why do you still need government data? Why is, you know, I'm saying groundwater is not measured properly. But why do I still need government data? Because when you go back to the government to ask help, they will send you back saying, okay, go do it with our data. Okay, so you cannot ignore the data. You cannot say no government data. You can add it and then you can do some analysis. It gives you higher spatial and temporal resolution, which is needed. Okay, so government data, please use it. Don't ignore it. Maybe you have to clean the data. I'll give a session on data cleaning and proxy data if needed. But don't ignore the government data. If you start ignoring the government data, since I'm also from the government, you're also from the government, it's not taken up in a good fashion, right? So you need to make sure you acknowledge the data and use it properly. So there are multiple ways where data are collected. There is a human-centric measurement where people go and use instruments, handheld devices, and take measurements and come back. Your groundwater is measured like that. Your crop cutting experiments are ground-based. Then you have your DGPS-based measurements where they take differential GPS in the ground and measure elevations. And then you have your satellite-based instruments, which were talked about by Professor Raghu and others. And you have your drone survey, which you are making a very good drone lab. So there are multiple data. Now, why don't you just combine all this to make some meaningful data? Okay. Otherwise, each one can stand by itself. Yes. But to get it more inclusive, you need to add the government data. So this is how it looks like. Okay. So you have the resolution going up in your spatial resolution when you climb up the ladder of the remote sensing devices from your phones, drones, your aerial vehicles like small planes, and your satellites. So you see how the spatial resolution is going up, and your temporal resolution is high here, but you can get more temporal over a longer scale here. What I mean is, here you can get it every day, but it's too expensive. So you could go to a satellite which can take twice a day, once every 2 days or weekly, but it can take for years. For example, satellite data is available from 1960s, at least for India, for the land use land cover. So you can see how things have changed. This is getting lesser because it is very expensive to fly planes, but drones are overtaking that. So drones are kind of supporting both the ends. Okay, so this is where don't use one device. You can get this data from the NASA ISRO websites. You can get some of these from some vendors. Your drones are what you collect, and your surveys are happening also. I need a battery. Battery. Okay, so synergized map of crop area mapping. So this is a term which never existed. Synergized mapping. Okay, so we have trademarked it in IIT Bombay. What it actually means is you're creating synergy between the data and making new data. Thanks. Okay, so this is how the resolution is improving, and you have data integration for other purposes such as crop insurance, crop management, subsidy, etc. See, what I'll tell you a trick about data science. It's a good to collect data for a long time. You will never know how it can be used later. Okay, nowadays data is very cheap. As I said, your Google just searching is converting into a business for others, right? So keep collecting good data, and then once it is a long term, then you can make some good correlations and causalities to understand what is happening. Like for example, people didn't know what is the connection between groundwater depletion and farmer suicides, and we found it after a long time data set in Maharashtra, especially. Right? So database for futuristic questions. You don't know now, but I think that is what Kailash is also doing. He's collecting a lot of data, and then that database is going to be rich one day after 10 years, after 15 years, when there is a microclimate, a weather system which is generated inside campus. Okay, so I'll give you one example so that you can now visualize how it looks like. Okay, you have a smart ag plus public participatory management where you have ground data, you have remote sensing data. What is remote sensing and near sensing? Anyone? What is remote sensing? Sorry? Remote means far away, right? Sensing means you are collecting data. In short forms, without touching it, it is remote sensing. Okay, if you collect data without touching it, it is remote sensing. But because that is too vague, your satellite is a remote sensing. Your phone is also a remote sensing because you're not touching a plant or touching anything when you take a photo, right? So for that, they have near sensing. Near sensing are your phones, your drones, all are called near sensing. Whereas your crowdsourcing data is where you as students, farmers collect data. Okay. And that is what I'm saying. Your phones are automatically collecting data now, right now sitting there. Okay. When you're traveling in a car, Uber, Ola, you will actually give data to the Google server on how the traffic is. Google is very accurate. How is Google very accurate? Any time of the day you go, it is accurate for the traffic. Okay. So better ownership if you include crowdsourcing. That is what I'm trying to say. If you have just satellite, if you have just drones and no crowdsourcing data, then people will not collect it and own the data and take ownership for agriculture 4.0. So include them. And for that, you need to make the devices friendly to the people. It should not be too technical. Okay. It should be very easy to use. Your smartphones were very tough, but now everyone does it. I always say that when an app is made, they say, how can a farmer understand? You know, they're not going to understand it. Who taught them TikTok? They use TikTok a lot. Who taught them Facebook? They use Facebook a lot. Okay, so this is something which their life is dependent on, and they have the choice to come to cities. Like my father went from a village to a city, right? So, but the farmers are still there, some farmers. So we have to appreciate that. So there's something that is holding them back, and just teaching them should be able to. What are oh. Should I share? Oh, there it's not. Down. Any questions so far? Yes, no? I'll just go through the slide because this is words, but I'll tell. So once you have this smart system plus public plus government data, you have better ownership, better management scenarios, and an overall understanding. Because sometimes your satellites are giving data, but the farmer is laughing, I know what is happening in my field, right? And you have IMD data, but he knows, no, there is no water that day. So there is more overall understanding and including everyone in the decision process. I'm going to show you a case study which I've done with international partners. Which one now? HDMI auto. It will start with share here. Here you have business projects. Sorry, projects. No, all I'm saying is remove the net. And we'll just keep the directly to this one. And then this F something else. Then we'll share screen. Have we duplicated? Now my part is share. system, it's the same system. No? We should stop and leave this meeting. Can I leave this meeting? Stop. Stop share. All grow turmeric. That is a change that we need, and that has been done because of an ICT IoT tool. The government cannot go to that level and change that, right? So you have change how they use the water. Those who are interested, please go to this app called MyWell. It is free and everyone can use it. Okay, and you can see how other data are also mixed. The water quality data from the government, your rainfall data from IND, but you check them and your groundwater well data from the farmers. So all this is put together in one package as a water budget, and then you have these good heat maps. No, not too much technical. If it is red, water is less. have to pay for the time and expertise. Okay, in precision agriculture, how can it help? You can have all these networks connected together. You fly a drone, and drone sees where the water is released and how much the crops are getting water. You see, it's mapping the crop area, the leaf, healthiness of the leaf. Not sure it's not coming, but anyway. So you can see on the drone, below the drones, it is taking an image. Okay, and all of these are sent to the microprocessor and then the cloud and then goes to your mobile phone. So this is how ICT tools work together and give you an information. After some time, what you could do is you could let the phone release the water from here. Okay, you don't have to go down to the pump or the well to start the pump and then supply the water. This is what Jain Irrigation does a lot. But it's not an NGO. It is a consumer-based company kind of thing. But still, you have this automation done because a lot of migration has happened. Labor cost has increased, so you don't have it. I'll keep this for your reference. What kind of drones, what kind of sensors can be used? But you get the idea. Precision irrigation means you can say which patch needs water because this patch is more red than this. So only this patch is needed, so you can let the water run, but only open it in this part. Okay, all this is now controlled from your phone, from the comfort of your home, and more precisely you can do. And there is some AI deep learning methods you can do on training the data set, which makes your model more efficient. Okay, the dam water release is also based on ICT IoT tools, where you can have soil moisture sensors. Again, I'm picking from studies, okay, recent studies, etc. So you can see that you can have soil moisture along your command area. And when the soil moisture and temperature humidity tell you that the crop is going to be stressed, then the dam water is released. Now, how dam water is released? They just release per day. Per day, they release it even if the farmer wants it or not. But with this ICT IoT tools, it gives you a system to take a decision to release water. Okay? And again, with the dam water comes until your canal area or the channels that bring you the water. After that, when it gets into your crop land, you have control. Or the WUA, which is the Water User Association, has control of the dam water, irrigation water. All these can be controlled by an IoT system. Okay, you don't have to waste the water. The water can be very smartly used between everyone. All you have to do is make sure how many nodes you have, collect it, map it using your remote sensing devices, and give advisories to farmers. Same with water quality, but since we're not much into water quality, but again, we just do the sensors. So sensors, instead of soil moisture, you can put sensors for probes like parameters like pH, turbidity, EC, NO3, ORP, etc., which can be helped to stop the water from releasing into the farms or do some treatment before it is being released. At the end of the day, I would like to come back to one or two slides and jump into the entrepreneurial track. You need a lot of maps, a lot of information that can tell you the story. So, for example, here you want to make a map to show why is that lake polluted. Okay, it is not just one factor, and this is what satellite does. It gives you a lot of data, bring everything, and then make a layer of data. Okay, we call it data drilling, where you have layers stacked, and then you drill down to take information. If you just take one layer, then only you're biased by one information. Okay, if you just have one information, like for example, top land use, land cover, and I'm saying because of the land use, the lake water quality is bad, and I cannot use it for agriculture, then it is biased on one data. But here, satellite gives you multiple data, so that is where multispectral images helps you. For example, agriculture, human, wildlife, climate, soil, topography, etc. Remember, your soil also can give pollutants. It's called natural pollutants or geogenic contamination. Okay, arsenic, fluoride, iron, which are mixed in the water. When you see water like very murky, it could be from contamination from a factory or contamination from the geogenic material, which is a rock. Okay, so you have anyone from Kolkata region, West Bengal? They would know more about arsenic contamination, right? Arsenic is not released by any pollutant industries. It's mostly by the rock which is under the ground. So here's where you make all these layers, and then when you drill down to pull one net data out, then you can better explain why this lake is polluted.
So at the end of the day, I won't have just one data explaining the lake pollution, but a mixture. It's called a weighted component of why this lake is polluting. Then that gives me a better way of managing. Should I manage my land use land cover? Should I manage my human wildlife interactions or where pollution happens? Should I manage my soil topography? What else? Okay, so all these things you can take into understanding the water quality. Okay, the last one is the drones, and everyone knows why drones are used and how they could be used for at least flying. But what it can be used is to also monitor your soil moisture. Again, now how it's done is you have contractors who come and then fly it. Okay, but the data is only being used by your set. In sooner or later, there could be a database where drone data can be shared. So, for example, you are buying data through a government-sponsored program, but it may only stay here. When you open the data for collaboration, then everyone can chip in. You can say that if you want our data, you should give us data. Okay, so then a bigger database creates, and everyone can be starting to use this data for better water management. And it's not going to stop because satellites, remote sensing are on a rise. This is last year during the COVID-19. The Dutch government invested around $1.5 million just on farming in outer space. Okay, and it is actually good, but it's also scary to see how many satellites are on top of us to monitor the planet. And it gives you very crucial data. Okay, so what you cannot go on the land and take, you can take from satellites. But sooner or later, everyone is going to do the space race. Every space agency is pushing for more satellites. What is remaining is how do you use it for information? How do you use it for farmers is where it's getting in. So I just do a small quick framework how it could be done using a groundwater example for farmers or rural people. When water is not there, what happens is, for example, Chennai water ran out. What happened? The policymakers said, okay, let's buy water from different areas, bring the water in train. And then they gave the Chennai people drinking water, okay? But it is a short-term solution. There's not a long-term solution built. And that is where this building framework can help. So you collect data from ICT, IoT tools. What is big data is data coming in a large frequency and large volumes, okay? And you cannot collect such data by ground. Even census data is big, but you cannot call it big data because only once every 10 years you get census data. Whereas your satellites, by default, it is at petabytes, which is 1,000 terabytes, okay? So every day, every hour, there's like literally petabytes of data coming in from satellites across the world. So all this will come into big data, your satellites, your ground truthing, surveys, your smart tech, ICT, IoT tools, agriculture 4.0, and your crowdsourcing data. All these data should come into a pool of database, as I said. You can have create a database, and from there you do your research, training, and extension activities. Now you'll have a better way to solve the problem of water, not to just buy and give the water. Okay. So with this, going to stop with the agriculture 4.0, how to collect data, why to collect data. But I will jump into the entrepreneur track for GIS and data experts. When I say GIS, it also applies for the data that you collect through ICT, IoT tools. Okay. Lots of data, less professionals to work on. This is the sad truth on map ideas. Okay, and this is not only for India, everywhere. You could see the private sectors are opening out a lot of data. Okay, for example, all the satellite data exists, 3 hours, 5 hours daily, and then your normal data exists. But why is it not converted to an information or an app for farmers? Okay, so that is the problem, and that could be a business, and a lot of businesses I will showcase now. So SpaceX, everyone knows it's not a government agency, but they are taking over NASA, right? At least in the launching part, which is one of the strongest poles of US, and they had to give it to them because they did a better job and much more less cost efficiently. And from there, the data has been now spread to multiple agencies. So ArcGIS is a solution by Esri, and Esri also uses and gives a framework. It is agricultural GIS, and it is a startup. Okay, This is an example from the US I'm giving, but think how they've opened out the market for people to collect data, apply it in a smart fashion. See, when we were kids, or even like 5-10 years ago, there was no Swiggy or Zomato. You would just go to the hotel and buy and come. A smart guy, all he did is he just connected the dots. Oh, here's where Chinese food, here's where Indian food, here's where the fast food is there. Connected the dots and put it on an app, and he's earning millions and billions. Okay, there is an infrastructure behind it, not a doubt. But you can see how a small information has converted into a big business as a startup. There's not much difference between Swiggy and Zomato or Ola and Uber. When you use it, I'm saying only the price is different. But there are multiple startups. So just because one person is having it, need not say that you cannot have it. You can also do it if you can have some better performing abilities or localized solutions. For example, if all your Parbani universities, 8 district farmers are agreeing to one app that is going to be created by your university, that itself is a big business. Because only they will be using it and they are your stakeholders. No one will dare to come in and sell their product, right? And you've already created a good rapport. Like, for example, Gopal sir has said a lot of farmers come here to look at these things. And now you're going to give them a solution through an app. Tell us this data is all there. It's going to be put in a nice package as a gift as an app, right? So, and this is not new, and it's not that the Indian government can stop, because so long they were stopping, but this year it has been open for private sectors. I know how many of you saw it. Your military has been opened up. Leave the business attitude, leave the politics. But this is what the reality is. Okay, the launching is going to be done. The analysis of data is going to be done, because the government agencies were not fully doing it, or they want a different angle. Everyone wants to be like Singapore, right? Oh, why is Singapore clean? Why is Singapore's metros not? Because I worked in 1 year in Singapore. I'll give you the example. None of them are government owned. It's all private. Okay, so private means you can hold them by the shirt and ask, why is my train late by 2 minutes? Government, you cannot ask. So the government has that control because it is a private. We were doing flood modeling in Singapore, and flood is meaning not the tip level like in Chennai. It's up to the ankle. If your shoe gets wet in Singapore, you can sue people because you pay taxes. Why? Because the cars are very expensive in Singapore. You have to pay 3 times the tax. So when you get into the car with a wet foot, you're actually damaging the car, for them at least. So they can actually sue people. And that's why it's on time and everything else. People only talk about how clean Singapore is, but you're the one who's trashing your own street, right? So it's give and take. No, don't just compare Singapore, but people are also working till they die also. So coming up, opening up Indian state sectors for private reforms. Lot of private reforms are going to come, and you students are in that space where you can propose solutions and think about creative applications in civilian, military, and other agencies. Then there are some agencies which already are doing it. For example, Nanjing database has a lot of data that is being collected, put in fine DVDs, and then they give it to you. Okay, and then it can be leaked out. Someone is leaking it out because it's a DVD, right? Which is sad, but you still have to pay for this. And then here also you can see another agency, Ramsey. Yeah, they also have a lot of good India map data products. You have to call it product. Just data doesn't get you the money. It's a product, it's an information. Okay, so collect the data, clean the data, collaborate the data with other sources, your ICT tools, IoT tools, drones, etc., and then make databases, thematic, country-specific solutions. Solutions is more important, not just data and information. Okay, and the last, before I complete my slide, I'm going to give you an example of MapMind India. See, ISRO has had the highest, or it is the only monopoly player in space research in India. However, MapMind India took over as the leading data information provider in the country. Okay, they are a $1 billion industry which started like a student project. And they are now giving data and information to every single player in India. I'll show you the examples. So what they make is they take the data. For example, they take a Google map, they take an ISRO map, and then make these customized maps. Okay. For example, as I said, if you're going on this road and you like an ice cream which is kind of Baskin Robbins or Amul ice cream, let's say, all the Amul ice cream will be highlighted in your map. It's a personalized map which is tailor-made for you, and the personalization comes from your Gmail account, because in Gmail you'll be buying, or your big basket or something, you'll be buying, and it is kind of a business model, but it's also a personalized model. Okay, so it's just not a garment, it's just not a GPS device, but it's a very personalized map. That is what Map My India's garment device has. Or what else does it have? It has map data with a lot of features, very rich features which no one has. It has geodemographic data, how many landholds, better census data, etc. And something which is new is called real view. So they have, for example, a street, and they collaborate with the people on the street, the cameras and stuff, to give a real-time visual of that street. So when you're driving, you don't want to get caught in the traffic, or you don't want to, you want to see if there's a parking lot rather than going round and round. For that, you can just buy real view, like a membership, and any street that they have collaboration, you can see where the live session of the street. End-to-end technology solutions, and these are their partners. You can see they trust maps, and including ISRO. So ISRO is right there, Government of India is there. The COVID dashboard for India was done not by ISRO, but by Map My India. Okay, so just go and check these resources. You'll see how a private agency can do very big work with data, with GIS and mapping. Okay, end-to-end technology solutions to solve critical issues. This is a good one, e-lock. So instead of giving you an address, which is this big, right? You have to put your house address, your street address, and then everything XYZ. So the address becomes big. When you do a Google search, Uber, for example, here to Fern Hotel where you're staying, I'll type Fern Hotel, Residency, Parbani, etc. But in this e-lock, every single building is given a number, okay, in a particular village, in a particular district. So what are you doing? You're minimizing your data, and the storage of the data becomes cheaper. Okay, so this is just a simple technology. They said, okay, these are the buildings. I'll put different numbers to the buildings. I'll integrate it into my ICT drone imagery, and I'll give an address. No one can stop you from giving an address. I can label the chair as 1, 2, 3, 4 from this side, or 1, 2, 3, 4 from Avinash's side. Right? So any side I can do. That is my suspicion, and that is what they've done. They've used a single address, and that can go into the map, and they sell it as a product. So Map My India, nothing much different. You can see they have much more features. Features means in a street they have every single store map in the map, whereas Google Map will not have such details. Okay, so that's where they differ from Google Map also. They have the data of population much more in detail. They have the end-to-end solutions. So this you can do, and I'll give you 2, 3 examples of the agricultural network. One is called OMSAT. So OMSAT is something which takes images of agricultural fields using drones. Okay, and it gives advisories, and also it is a collaborator with all these international bodies, so they know which models to use, pest control. They have a database of the plant attack, the pest attack plant, so they can quickly tell you what is the solution for the plant pesticide. It will be half of it is lethal, right? And then satellites are already coming into the OMSAT. So the OMSAT picks, so it's just a dashboard. You give Parbani, it will pick which data set is good for you. You don't have to search Sentinels. You don't have to search list 3, list 4. It will actually update and then give you the right thing. Like your Google Earth. Whoever uses Google Earth Pro, if you zoom down, it will pick the right satellite for you. You don't have to select a satellite. Okay. So this is one such technology that can help. And creative and futuristic mapping, which is needed for you to do a business, is you can create good standalone dashboards. Dashboards are very cheap nowadays, but the information behind it is very not up to mark. So if you can be creative on how to create the data and use it, that is a good startup business. Dynamic user interface, which means not one way. For example, I might be very cautious about what data I'm going to put online. So I'll be putting a very specific data. I won't share my data with the vendor. I'll say, for example, Map My India. I want to map my farm, but I won't give you my farm address. You give me a dashboard. I put it on the dashboard, and I take the data I want. So those kind of dynamic user interface is needed. Just not one way. Okay, one way is just I have a open dashboard. I download data and use it. No. So people are wanting dynamic interface. So like YouTube first was only one way. You just go there, see the videos. Now it's two ways. You can make a video, you can upload it, and everyone can watch it, and you can become a millionaire also, like a business. So GIS analytics, AI/ML. I won't get into the AI/ML part much because that is a higher computing thing. But what I'm saying is just collecting data and putting on analytics GIS is fine. But you can also do higher end analysis using AI and ML, artificial intelligence and machine learning. And then the last and not least is the IoT and automation, where you have Internet of Things and you automate everything, right? So instead of having you going and turning it on, your fan, your switch, everything is now automated from your phone or your tablet. And better mapping of services can be done. For example, flood, etc. Right? So all this you could do, and it's all open source. You can go to MapMy India, you can see all these, but you have to pay for using it and giving you the idea. So they're like Tesla. They give you the idea. You there if you want, you can do it. It's nothing special. It's just they tell you what each one is. But how many people want to do it is the question. First, what I say is create a stakeholders, create your market, then jump into these kind of products. As I said, for Pardhani, all the farmers agree that you have to give NAHP has to give the data. Then you have a market, you have a business model. So how many startups don't do well is because they have brilliant ideas, but they don't have the connection to the market, right? Then it is just failing. So for that, just be careful. It will be a very success like these guys. So these guys started in a garage. Now they're $1 billion listed industry in India. Okay, they're bigger than Google for India. That's how big these guys are, MapMy India. Okay, so conclusion days forward. CC has impacted, climate change has impacted agriculture, water, everyone knows this. And climate smart, or the smart word comes from the ICT, IoT, all those tools can help reduce the issues. A lot of monitoring and management is needed, not just informing that there is a flood, but there should be some monitoring and management. Data collection along with management and smart market connections can make you your ICT, IoT tools sellable. Okay, all these are models which are given from farmers. See, we started the MyWell app, but you cannot sustain it after 5 years, 4 years. Someone has to buy it and then use it as a service, because there's nothing called as free in anything, right? We got the money from ACIR. Otherwise, am I going to do the work for free? No, right? So if the funder pulls out, then the farmers themselves say, let's support this program because it has helped us use groundwater better. Data and information as entrepreneurs. Okay, so don't just limit yourself as a product. It has to be a product to sell. What product does Google have? Okay, what product does Ola and Uber have? They don't even have cars. Okay, but now they have cars as used cars, but initially when they started, it is just connecting the dots, and that connecting the dots is done by an ICT IoT tool. Okay, so all this will come back to your agriculture 4.0. In tomorrow's lecture, I will jump into more GIS, advanced mapping, more into agricultural stuff. Yeah? This I would like to thank my people who invited me and all the data platforms I use. Thank you. Any questions? I hope I was not too fast. Thank you.
Thank you very much, Dr. Chinnaswamy sir and Dr. Gaur madam, for acting as a speaker and the co-chair for this session. Thank you very much, Dr. Chinnaswamy sir, that you have given basic information about the effect of climate change on agriculture and its impact on the agriculture and different agricultural water management issue in India. Also, give the brief information of smart tools used in agriculture and collaboration with the examples and multiple uses, the very beautiful pictures. Now, the next speaker for this session, Dr. Entrepreneurial Startup, a principal scientist, ICAR, Indian Institute of Science and Bhopal, and Dr. Praveen Vaidya sir, head of the department, Soil Science and Agriculture Chemistry, DNLP Permanent. I also request Dr. Pawar sir to honor this bouquet, Dr. Anand Kumar sir and Dr. Praveen Vaidya sir.
Yes, please come. Welcome.
Thank you, sir. Again, request to please welcome Dr. Vaidya sir, who is acting as the co-chair for the session. So, before inviting Dr. Anand Kumar for the presentation, I am quite appreciated to brief his achievements. He's having the professional experience of 22 years in this field with his research specialization on conservation agriculture, field management, watershed development, soil and water conservation, agriculture in weedy ecosystem, software development, and in soil health management. For his work, he is honored by different awards like Vishwavidyalaya Gold Medal given by the Jawaharlal Nehru Krishi Vishwavidyalaya Jabalpur, Madhya Pradesh. Again, with the ICAR Award for Outstanding Interdisciplinary Team Research in Agriculture and Allied Sciences. So I request Dr. Anand Kumar ji for his presentation under the topic Information Technology Based Interventions for Sustainable Agriculture. Dr. Anand Kumar ji, please.
Start with some of the basic things and this is information technology. These things. So, agriculture and information technology both are two different ends. Agriculture is age-old practice that we are practicing for our livelihood since ages, and information technology is a recent advancement made by human for dissemination of informations and knowledge. So these are two different ends, and we are trying to integrate these two things together
for the benefit of the agrarian society. As we all know that agriculture, Indian agriculture has developed through ages, and particularly after independence, when it is said that India will die because of its hunger, we fought and we came out of that tag, and we are self-sufficient in food and production. That is one story. Another story is that we gained self-sufficiency in food and production. Definitely, there are some second issues that we have faced in the form of degradation of resources, particularly soil resources, water resources, and our agricultural land is, it is almost constant, 140 million hectares. From that, we have to grow all the foods. At the time of independence, about the per capita availability is about 0.5 hectares, and now it has come down to less than 0.1 hectares. So that means that our land to grow food in production for one person has reduced from 0.5 hectares to 0.1 hectares, and by 2050 it will further go down to 0.08. So that's a great challenge. On the other hand, the technological advancements are continuously taking place, and these technological advancements can help agriculture to improve and sustain the resources, so that our present food production requirements and the future requirements can be fulfilled. If we talk of globally, the global population will be by 2030, 2050, it will be 9.7 billions. So, and the food grain production will further increase by almost 50%. So it means that there is further pressure on the agricultural lands to grow more food, because we have to grow almost 50% more food by 2050 as of today. So this year we are projected that it will be around 316 million tons of food and we are going to produce. But by 2050 we have to go to the level of more than 450 million tons. So that is one thing, and another thing is environmental security. We have to maintain our environment in such a way that our livelihood can be sustained. On the other hand, to meet the food requirement, intensification of agriculture is the only option with us, because there is no other chance of increasing the land. So that is another pressure we are having. Another important issue is the climate change. Our climate is changing and we are facing the consequences already. The carbon dioxide levels have reached to the extent of 415 ppm. If we talk of, we compare it from 2017-50, it was around 270 ppm in the year 1750, but now it has reached to a level of 415 ppm. So that is another concern, growing concern, and mostly attributed to the fossil fuels and burning of residues. So that is another challenge in front of us. And the safe food and environmental issues are there. To solve them, organic farming, natural farming, and all those things are there to sustain the productivity of our system. So the agricultural development, technological development, they differ globally, and from globally, information technology can assist those technological advancements to grow locally. So those technological development which has taken place at a far different place or far different country can be brought to our country with the help of information technology that is there, and we can. This is possible with the help of information technology, knowledge sharing, and all those things. We can also improve our technologies. The purpose of this information and communication technologies is to transfer the desired information from one point to another point very quickly and in time, because in agriculture time is very important. If you have lost the information in time, it has no use. So that is very important. And this information technology has made this impact. How this information can be transferred from one place to another place, or from resource person to the end users. Then that is beneficial to everyone. So that information technology can help in that aspect. So information communication technologies are comprised of many things. As I told, we are living in an era of information communication technology. Everybody is using mobile phones, television, and one or the other form of information communication technology we are using in our day-to-day life, like networks, mobiles, devices, services, applications. All these things help in processing, management, and exchange of data, information, knowledge with target audience, either it may be to a single person or a group of persons. All those things can be shared. And the transmission takes place from traditional telecommunication means television or video means, radio means, CD-ROMs, cell phones, smart devices, computers, any kind of thing. And now the recent developments are sensor-based developments are taking place in agriculture, and we are sensing that in-field direct measurements of moisture and nutrients are being practiced. So all those things are developing. And geographical information systems applications are there. My earlier speaker has elaborated more on that. UAVs, unmanned aerial vehicles, that is a more recent advancement, and satellite, etc. So all these things are there, and we have to use these tools. These are basically tools that we can use for our benefit for dissemination of agricultural knowledge. So, as I told that agriculture is there since we started growing our foods, but IT is a recent advancement. And initially it has been thought that it will be very difficult to merge these two different branches, but it has been proved wrong again. And IT is making good interventions with agriculture, and we have a number of successful innovations that are helping us in making better decisions, making better planning, and all those things which can help in sustaining the agricultural systems. So artificial intelligence and machine learning and the internet are available, revolutionizing and modernizing agriculture, and they are helping in modernizing the value chain also globally. So that is another impact of digital agriculture. However, if we come from as compared to global interventions or global developments, still we are in initial phase. So we have more scope. In fact, I can say we are in initial phase, so we can have more scope to develop things to flourish in this field. So and we can successfully integrate and utilize these digital technologies to revolutionize agriculture. Definitely, it may take some time because agriculture persons are expert in agriculture, and technological persons are expert in techniques. And until or unless there is a cohesive bond between these two fields, we may not be able to generate good quality support systems for the benefit of the farmers. Because our farmers need very simple tools and techniques which they can use. Otherwise, if complicated things are presented to the farmers, it may not be possible for them to use those things. So we have worked in these fields, and practically I will show some of the software decision support systems to you, which we have developed during last 20 years or so, and which are used by farmers or the end users actually, which are helping the end users. Though I am not a man from information technology, I am man from agriculture. But I learned something, and I am practicing some of the things. So I will display some of those things to you directly, how those things are working, and those complicated things have been made to be used in one click. That to that extent we have done solve those complex issues with the help of information technology. So that I will show you after some time. So as I told, IT can help in many ways in agriculture sector, like it can assist in as an analytical tool for soil, for crop situations, climate, market, input users, input availabilities, infrastructures, and demographic and socioeconomic data access. So all analytical wise it can help. Then it can provide also solutions when we have good analysis of information. It can help in efficiency, transparency in distribution of water users, resource availability. Producers can become providers of data, technology transfer, productivity enhancement, and definitely when productivity will enhance, definitely there will be more better economy of the farmers. So that can be that solution can be provided by the IT tools, and it can act as a bridge between the rural and urban areas, and farmers can access the services and policies and schemes that are government that are services offered by government to the rural people. So all those things can be done. Application of these results or data can be made for using in the field directly in the field watersheds, then planning of water harvesting structures, land development management programs, soil health systems. All those things can be improved with the help of information technology. Some of the ICT tools, very common ICT tools, everybody is using these tools for either for storage of digital information, the recording of digital information, and communicating this digital information from one person to another person. All these are very common tools we are using, but maybe we are not using in that way for the benefit of the agriculture. We are using those for communication purpose and all those things, but maybe we need to use more these tools for the benefit of the agriculture. Some of the web browsers and search engines are available from where we access the information, and we can also share our knowledge through using these browsers and search engines. The social media tools are also available, and we can use these tools also for dissemination of agriculture knowledge. Lot many things can be done using these freely available social media tools. So the use of ICT in agriculture globally has made a lot of impact, but still in our system in Indian agriculture, we need lot of more from this. And recently, Internet of Things has become very popular. Sensors are being developed. We can live sense the soil, and like moisture sensors are there. Which can be used to assess the soil situation, and directly those information can be translated, and irrigation can be applied to the field. To that extent, IoT is being used now. Another thing is sensing technology. Drones, UAVs are now becoming very popular. That gather vital information for the farmers on soil properties, air, crop health, etc. These data enables farmers and agribusinessmen to take right decisions that can be taken with the help of these tools. And these tools ICT can help in a big way for precision farming. When we have good information, definitely precision farming tools that have resulted in increased efficiency and reduced cost of all the resources and cost of production. So that ICT can help in that way also, and it will finally help in decision making process. Farmer has to make a number of decisions, and those decisions are to be taken instantly. So these tools can help the farmers in a big way in taking instant decisions. And it has ensured, ICT has ensured that in a click or in a touch, we can connect with the global networks, and we can collect information to what we need. And it can help in a big way for policymakers also. Adoption of ICT will enable them to gain better understanding of the situation at ground level, and we can policymakers can make better policies for agriculture, for the development and upliftment of agrarian society. And the most important thing is at all the times experts may not be available at a remote place. So ICT can remove that barrier also. Now, an expert sitting in this hall can be accessed, will be accessible to a farmer sitting in a remote place through with the help of ICT. So that is the very big help IT can extend to the farmers. As I told, IoT, Internet of Things. In future, it will be used in Internet of Actions. Means assessment of the situation and action taken. Both things can be taken. Decisions can be taken remotely. No human interference may be required. Machines will do everything, and they can assess the situation, and after assessing the situation, they themselves will give the solution and solve the issue. That kind of things will come in the near future. And by 2030, these things may become reality. UAVs, the drones are now being used in a big way in the agriculture sector, and particularly in assessment of damage, pest occurrence, and even to the extent for management of this pest and disease. So monitoring and all those things can be done in a very rapid way. They are very fast, and they can assess the situation very fastly, and provide information immediately to the user. After assessment, they can also help in spraying of the suitable chemicals for effective control. Even these things are very effective. These drones are very effective in case of fields where undulation is more, because in undulated land topography, manually operations are very difficult. But UAVs are fixed with chips or sensors. They can sense the altitude, and with the help of those technologies, they can change their position, and that way they can very effectively apply chemicals in the field. So digital agriculture can make a big impact in India, and they can help in increasing the agriculture productivity, and not only increasing the agriculture productivity, they can help in lowering the cost of production also. And by that way, they will help in doubling the farmers' income. That is another target we have to for all the agricultural scientists. That is one of the targets. So internet information technology can help in that way also. Preventing soil degradation. We can assess the situation very fast now, and after assessing the situation with the help of IT tools, we can take necessary corrective measures, and by that way we can prevent the soil degradation also. When we assess the field situations very effectively, what we can do, right now farmers are applying their pesticides on the basis of their experience, or just the neighboring farmer is applying, so he is also applying. Now, with the help of ICT tools, we can assess the situation, actual field situation, and based on that, we can apply the pesticides. That way, we can save on those not only the application of pesticide, but also we can reduce the cost of cultivation. And we can promote effective and efficient use of water resources, improve farmer socio-economic status. It will also help in reducing environmental and ecological impacts of modern technologies, and implementing these technological solutions will will help in more reliable farm management and monitoring. So all these things we can apply ICT tools in a big way in all the fields of agriculture. Of course, IT tools are very accurate, but only accurate when we give them good data. Otherwise, this will be ego. Means if you have not given, if your analysis is not good and your data is not good, it will be garbage. And this, whatever IT tools you will be using, they will give only garbage. So when we use IT tools, ICT tools, your data should be very sound. Otherwise, whatever analysis you have done, it will be all fitted. They will land you in a wrong place. So you need to have very sound data. Only with the help of very sound data, if your data is like gold, you can get you will get a very good result, and with the help of that data you can generate good analysis. So that way you can have good program, good planning, and you can execute all the programs successfully. Otherwise, if you have don't have the data correct accuracy is not there, it will be very difficult, because agriculture is a very diverse and very complex system. So that you need to take care while implementing all these ICT tools. Another application of ICT that I was studying, that we have done some work on that, decision support systems. So these decision support systems are all interactive computer-based systems, which are intended to help the end users by utilizing the ICT technologies, data, documents, knowledge, and the models to identify the problem and solve the problem, and complete the decision process and task that to make a decision. So all those things can be done with the help of decision support systems. It improves the performance of decision makers by making the time and by reducing the time and human resources required for analyzing the complex situations. Because all agricultural computations are very tedious and time-taking, and farmers cannot perform all those calculations, and can take decisions or perform the calculations correctly. All those things are there. So these tools can help in a big way. These decision support systems consist of a knowledge base from where it compares the things. A knowledge base is there. Inference engine is there, where different situations are analyzed. A database is there. Explanation model is there. If this is this, this is that. All those decisions it takes within system, and after that, a knowledge base editor is also there that helps in taking decisions. So this knowledge base contains the rules of inference that are used for the reasoning process. So when I will display some of the decision support systems, I will tell where there is work. So when we develop some decision support system in agriculture, there are certain prerequisites. First is we have to keep our target audience in our mind, that our end user is a farmer who may be literate or who he may be illiterate also. So that we have to keep in mind. So our system should be very simple, which any person can use. Maybe even if he is not knowing computer system or whatever he is not knowing, he can use. He should be able to use that system. So it should be very simple. It should be very user friendly, because many times I have seen, even I myself has faced that some complex models are there, and we ourselves are. हमको डर लगता है कि इसको कुछ कर देंगे तो क्या हो जाएगा. So that should not be there. Consider the situation of the farmer. So farmer का कैसे, इसलिए आपका सिस्टम इतना यूजर फ्रेंडली होना चाहिए कि बड़े आसानी से फार्मर उसको यूज कर सके. इट शुड बी इंटरैक्टिव. आपने कुछ गलत कर भी दिया तो सिस्टम आपको हेल्प करने वाला होना चाहिए कि आपने ये गलत किया है, इसको ठीक कर लीजिए, करेक्ट दिस स्टेप. इट शुड बी लाइक दैट. ऑफ कोर्स इट शुड बी नॉलेज ड्रिवन. किसी भी डीएसएस में जो है आपके पास में नॉलेज बेस इतना स्ट्रांग होना चाहिए कि कोई भी सिचुएशन, कॉम्प्लेक्स सिचुएशन भी आप उसके सामने में देंगे और उसको सिस्टम को इतना स्ट्रांग डेटाबेस होना चाहिए कि गलत इंफॉर्मेशन, इफ यू हैव फीडेड रॉन्ग इंफॉर्मेशन, it should tell you that you are doing wrong. That kind of thing should be there. Scientific basis, of course, if scientific basis is not there, then it will be difficult. So your system, whatever support system you have developed, it should be validated with paper testing should be done, and field testing should, after that field testing should be done, and whatever results your system is giving, it should be accurate. So all those things will come on the validation and evaluation of those systems is properly done. Then only we can say that our system is successful. So all these are prerequisites for, at least for Indian conditions. And one decision support system we have developed is for nutrient crop nutrient management. I'll give some basics of that software. So when we interact with farmers, farmers always says that I am not getting potential yield. Even I'm applying sufficient quantity of fertilizers, even then I am not getting potential yield. That is most common problem with most of the farmers. So we all know that crop yield is a complex thing, and it depends upon a number of factors. Like climatic factors, plant factors, varieties which you are growing, your soil conditions, all those things influence the outcome of the final outcome of the crop. So, and of course, nutrient management is one of the major thing that plays an important role. So, the resultant will in the form of final yield, but we are not getting those yields even after applying all the factors of production with all the nutrients. So this is one of the real world nutrient support system. It is called the black box, or which is commonly known as black box or type of decision support. And in this system, we give blanket recommendation. Okay, this is the idea you take, and you can get this target yield. That is the basic thing. That this is the idea. You take 160-40, you will get 50 quintals of yield. But when farmer practice it, he hardly gets 35-40 quintals of yield. So that difference is there, and that is why, because we are not taking the various factors which govern the yield. So that is called blanket recommendations or black box type of decision. And we need, farmers need for nutrient management particularly, farmers have a number of management decisions to be taken. What to apply, how much to apply, when he has to apply, and what are the yield returns that he will get out of this. So that complex decision farmer has taken, and he has to optimize various things also, which nutrient he has to apply, at what quantity he has to apply, all those informations he needs. And when we don't take all those factors into consideration, there are huge differences in the expected and actual, and which result in non-judicious application of some of the nutrients, and some of the nutrients are applied either in excess quantity, and while some of the nutrients which are applied in the lower quantity. So those kind of things are there, and ultimately that affects the economics of the production. So because farmer did not get sufficient expected yield, so his economics will be affected. So what we need a ideal IT-enabled nutrient management decision support system, which will take into consideration all the factors of production. It should have a database also, data backup. It should have a data backup also on nutrient uptake, expected yield, potential yield of the variety, crop nutrient requirements, fertility status, soil efficiency to provide nutrients, fertilizer use efficiency, economics, environmental concerns. All those factors it should take into consideration together with production functions like choice of crop, resource, soil resources, nutrient availability, all those factors. And with a decision support mechanism, it should be able to provide an accurate solution based on optimal doses with better use efficiency, reduced environmental concerns, improved soil health, and that will help in getting higher yields and increase the economic returns to the farmer. So those solutions are required, and which can be taken with the help of this kind of decision support system, and farmer can take an actual decision. So, and this is the flow chart of this kind of system, and you can see that it has a resource input data for projected estimation. Then it should have a database also. It can import input data also from the user, and all those information should be processed to identify the optimal combination of the resources and the target yield. And all those input requirement estimations can be analyzed against the resource availability of the farmer. And based on those optimal yield, optimal solution, and resource availability, another decision can be taken by the farmer, which will be optimal for him. And finally, the optimal fertilizer recommendations can be suggested, which will be based on the soil site specificity, crop specificity, variety specificity, all those things, and ultimately the potential target yield which the farmer wants to go. And all those things will be processed in that system, and after that, completing all that decision-making process, the system will provide you a solution. And these softwares has been created using Visual Basic programming, and these are interactive softwares which can accept input from the user also, and can take some of the data from the database also. It can dynamically process the inputs, provide a ready-made solution to the user's requirements, help the user to obtain certain information. Suppose the user is not having information, and that information is required in that system. So the systems are capable of providing that information with certain input to the farmer. That if this is your crop, what pH is optimal. So that information he can get from that software, from that software, and it can provide warnings and suggestions on critical levels. And these are the basic equations which we used in nutrient management. So I will show some of the practicals. This is the software called crop nutrient management. This software we have developed in 2004 while I was working in NAHEP region. So this software was particularly for NAHEP region, and it has some input field where farmers user can submit his information, or otherwise here for two states database is there. For Meghalaya and Mizoram, database is there. If the user is not having his information, he can use this database and he can get the values for various soil properties. Like this, you can see this is from Mizoram, and farmer can. It is not working, so different districts are there. Then the village level, to the village level and to the farmer level, and that information can be accessed. Now you can see here that automatically the values are for soil testing values are available, and the farm for target is of 40 quintals for rice crop. The nutrient recommendation generated. Nutrient recommendations has been generated. No, it is not working. Okay. So, so you can see nutrient recommendations has been generated, and then different choices of different fertilizers are available, and farmer can use the choice of fertilizer of his own choice, and he can generate the fertilizer requirements. Suppose the farmer is having, or some researcher is using that software. What he can do, he can give optional data also of nutrient uptake, fertilizer use efficiency, and soil efficiency. All those data is there. He can submit that information, and he can generate a site-specific nutrient recommendation with the help of this software. And this software is having provision law for all kind of nutrient management, chemical nutrient management, inorganic nutrient management, then organic, then integrated. All kind of nutrient management systems are available, embedded within this decision support system, and any user can use any of the module of his choice. Another visual diagnostic tool is embedded in this decision support system, which is for identification of any deficiency of nutrient, and user can get information on the the problem of so this is for nitrogen. Now it is showing. Any user can visually see compare his crop from this one, and he can get information. Now, what is the problem? He can identify and how to solve that problem. All those things. Like this. This is for zinc. So, I will discuss some of the softwares also. And this is another software we have developed for the problem soil management. And in NAH, there is a problem of soil acidity, because most of the soils are heavy. So all the bases got bleached down, and there is a problem of soil acidity in soil. So to tackle that problem and to find out the line requirement for various situations, this decision support system has been developed, which is very useful in NAH visa. And it is also having some of the input fields like soil pH, desired pH, and soil type and liming material, cost of material, and if the user is not having the desired pH, there is a module available in this system. Using that module, anybody can determine the required pH and fill in this system. And after calculating, it will give the line requirement, material requirement, and the cost estimations also can be generated. And the system is also fitted with a module to compare various materials available for lining. So if the user is having all the information, he can submit that information in the system and find out which is the best material at the cheapest price he can use to reclaim his soil. That option is also available. Then we have developed this soil health card mission has been initiated in a very big way, and our institute has been entrusted with the responsibility of generating soil health cards. So we have developed a software for that also, and in this software we can analyze, after analysis of the soil, we can fill the desired information, like here it is filled, and all the details of the farmers can be submitted in this system, this soil card, and after submitting, it can generate. It can not only analyze and interpret the results. After interpreting the results, it will give the recommendations for fertilizers in two different sets of fertilizers which are commonly used, and along with recommendations for micronutrients as well as the organic fertilizer requirements. So this software is used by many persons and many agencies. Another software we have developed is for citrus production and management, and any of the information related to citrus production and management can be accessed utilizing this software. Even nutrient requirements, the nutrient scheduling, application timing, all those things can be generated using this software. And it has also been attached with the visual diagnostic tools, which will help in management of insect pest and diseases. So these visual diagnostic tools, with the help of these tools, farmer can match their samples directly using this visual diagnostic tool and identify which is the problem, and the solution is available within the system, so that problem can be solved. This is another software decision support system we have developed while working in Central Soil and Water Conservation Research and Training Institute. I have worked there also. So we used to implement watershed on large scale, but while implementing watershed, we came to know that there is big problem of planning in soil and water conservation aspects. So trenching is one of the most potential technology for addressing that issue, and we have developed this decision support system for that also. And that is a multilingual software. It is in English, Hindi, and Gujarati. 3 languages we have done. So again, here there are some basic input requirement is there, and if some of the basic input requirements are not available with the users, database is there from where the user can determine his values. So after entering all the values, we just need to click on what kind of soil is operating. All the information regarding calculations can be generated in one single click, which otherwise would have taken more than 2 to 3 hours time, and maybe within 2 to 3 hours time, the person who is doing this job might have done one mistake, and all the calculations will go in there. So that mistake is not there. This will generate accurate information. It's one single click, and after generating all that information, you can simply select the type of trench which you want to develop, and you can get the layout of your trenching design. You can take a printout of this one and straight go to the field and implement your plan. This is another with the trapezoidal cross section. Earlier was rectangular cross section. This is for staggered trenches with rectangular cross section. Staggered trenches with trapezoidal cross section. Everything can be done with the one click, and you can implement your plan. This is another test for warming system. This is another field where we can use this information technology test for warming. So we have worked on mesh core borer, and we have developed one for warming system. And then input data you need to have for temperature range and relative humidity. These are the input requirements. And after furnishing that information, you just need to press and calculate, and it will analyze the situation and inform you that there are chances of high incidence, low incidence, or moderate incidence of the test of mesh core borer in that particular area. So accordingly, you can plan your things in advance. That what this year, this is the chance. So we need to get ready. And all the information related to management of that particular insect is there. And that another software that we have designed is for farm pond development. Because many times we have observed that either the structures are over designed or under designed. If it is over designed, the structure will never get filled. And if it is under designed, a lot of water will flow out of the area. So to address that issue, we have developed this decision support system. And again, there are some input fields, and it will calculate and give you the final layout in different shapes. Whatever shape you want to do, it will provide you. It may be square, it may be rectangular, it may be circular, it may be oblong, it may be parabolic, it may be triangular shape. Whatever shape you want to do, it can provide you solution in one click. So we are also developing some of the software decision support system for assessment of physical properties of soil. Of course, these are value based. Some other applications which are very useful, like pressure cap is there, rice knowledge management portal is there, and we are Kisan, farmers portal, is our institute. So these are emerging technologies which can help us taking our agriculture in anywhere where we can take decisions based on scientific rules, and accuracy will be very high. Of course, to achieve these things, to achieve this accuracy using information technology, we need to update our knowledge also. We need to have very accurate data. That is the prerequisite, and they will contribute in increasing the agriculture productivity. Simply by within the resource, whatever we are using that resource only, we can increase our productivity by optimizing the resources with the help of these technologies. And many of these IT-based approaches are directly applicable in managing soil fertility, because you can analyze sensor-based analyzers are there. You can sense with the help of sensor soil with the help of IT-based tool, and immediately you can provide solution. It can bring about product traceability, marketing facilities will be there, disease management, and it can help in the overall sustainable growth of the farmers. So with this, I thank you, for patience hearing, and some of you may question also, and I will display at least one or two live demos. Okay, how easily this software works. You have to take it out to the desktop. Anyway, the system firewall is not allowing you to list the software. So you can have your questions. मैंने अपनी बात रखी आपके सामने, आपने अच्छे से सुनी, थैंक यू वेरी मच। और मैंने कुछ चीजें आपको दिखाई हैं, but lot many things can be done. एग्रीकल्चर फील्ड में स्टिल देयर आर लॉट ऑफ स्कोप। अभी एग्रीकल्चर फील्ड में आईटी का कोई बहुत ज्यादा इंटरवेंशन नहीं हुआ, एटलीस्ट इन आवर कंट्री, एंड लॉट ऑफ स्कोप इज देयर। any idea, even if you need some help, I am always ready to help people. So you can come to me also with this, your idea. I want to this, I will definitely help. I will definitely extend my help to you. And provided you have that data should be there. The data should be correct, accurate data should be there. And so before planning any software or decision support system, check all your data, all your calculations. Be ready with that, and then plan a visual system. This is what you want to show. Or consider yourself as a from both the sides, as a developer side, from the viewer side. Both ways you have to see. Then only you can come to know that what as a developer you are developing and what as a user you want to know. So when you compare both the things, then only you can develop a good software. Because what I have observed that very good software developer develops a software which is not useful for our user, or not for farmers user. So that problem should not be there with agricultural software. Our end user, always keep in mind that our end users are farmers, and we need to develop very simple user-friendly softwares or support systems which can be easily understood by the end user, and preferably if that can be generated in a regional language. That will be more useful for the end user. Okay. Thank you very much. I take this opportunity to thank the organizers, and of course, you can raise your questions first.
Student, you have any unit class about the digital support system, any question?
Yes.
One digital support system will determine the physical property of soil. Based upon which property you are considered. For the digital support, you want to determine the maximum water flow holding capacity. Very tedious process. How your software is trying to determine these PAWDs, plant available water capacity. Based upon the all physical parameters.
See, there are two type of systems. One is some of the data can be qualitatively that can be done, and some of the data can be done quantitatively. So, determination of physical properties is a difficult task, and some of the visual diagnostic tools type of thing we have, our team has analyzed, and they have given some scorecard type of system. That if this is this, you give this number, this is marks out of 10 in a 10 scale, and it is based on that system. So we are trying that can be standardized. We are still working on that. So that's why I did not show the whole process of that. We are working on that actually.
Just you can do the different code number.
Right.
The particular property.
Right.
And then you can determine the actual.
Exactly. We are working on that. Yes, please.
But I want to know that you are scientists and working day and night for agriculture. My question is, what will raise the speed of development if educated person or a student like?
My question is the speed of development of Indian agriculture. What is more important? Educated students who know these all the technology from their field coming in agriculture, or the farmers who are already in agriculture and will be part about this process. So, which among these two will result in increasing the speed of development?
See, every component is an important component. You have to gain knowledge, then you can analyze the thing. Because as a fresher, without having practical knowledge, if somebody wants to do something, he may not be able to perform. So farmers are having knowledge, deep practical knowledge, but they do not have that scientific knowledge. So we have to try and create a bridge where both the ends will merge and develop a system, and the science which we have developed and the knowledge which farmer wants, that can be bridged, and that gap can be fulfilled. That we have to try. Of course, all you young persons, you are more competent in IT as compared to our generation. So you can use in much more better way these IT tools. Of course, I am not a man of IT. Still, I learned small things and I implemented those small things to develop some software. So I have developed almost 12 softwares I have developed till date.
Any more question? Any new idea in your mind? Just ask.
There's some question.
I guess. No.
model in India regarding monitoring of any pest?
See, monitoring of pest, our some of teams are working on that aspect, and one model, one decision support system I have shown you for maize crop grower. See, if a pest forewarning system is to be prepared, incidence of pest is mainly dependent on climatic conditions which are favorable for the occurrence of that pest. So we need to monitor our agroclimatic situations prior to that crop, and during that crop period, we have to monitor all those things. And not only monitoring, we have to arrange all the data and compare that data with the occurrence of actual occurrence of that pest. And then after a number of years of trial, we can determine that if these are the situations, we have to generate all those equations first. And after generating those equations, we have got this pest forewarning system we have developed after 10 years of experimentation. So time requirement is always there in these things, and one of our institute is continuously working on pest and occurrence. And every institute, our institute are specialized institute for particular crops, so they are monitoring those things at their institute level. I have worked in one institute, and there we have that kind of data for one particular test. So we have developed that into a pest forewarning system. Of course, all the institutes are working, and on different aspects. Like here also, you must be having a department of entomology or pathology who are working on those things. Because as one institute right now, I am in the soil institute. So the pests are not my priority now anymore. My priority is soil now. So I am working mostly on soil aspects. The soil health card systems, soil assessment systems, all those things now I am working. Conservation agriculture I am working. So all those things. So wherever I have gone, in whatever institute I have developed some of the decision support system for that particular institute, because all the information required for developing that decision support system is available with that particular institute. So as you have asked that pest forewarning, of course, pest monitoring is going on in all the institutes for respective crops and universities also. So you are having the data. Of course, it is required to be translated into some value addition needs to be done, and that we can add with the help of information communication technology and develop a system which will help the farmers.
Soil science, read out.
थैंक यू वेरी मच। थोड़ा सा मुझे ये रह गया कि लाइव आप लोग को मैं सॉफ्टवेयर नहीं दिखा पाया, अदरवाइज और ज्यादा थोड़ा सा इसमें मजा आता, जो कि इसका कुछ फायरवॉल का इश्यू आ रहा है।
Thank you very much, sir, for giving the brief information on information technology based interventions in agriculture. Now, I would like to call upon Dr. Gopal Shinde sir to felicitate Dr. Anand Kumar Vishwakarma with bouquet memento as a Dr. Thank you, sir. Thank you very much, Dr. Vishwakarma and Dr. Vaidyaji for chairing this session. There is a small announcement for tomorrow's session. We continue tomorrow's session in hall number 18, Administrative Building, PNMTV Barmani. A session will be start rightly on 9:45 a.m. sharply. So I request all participants to gather at 8 a.m. For enjoying their breakfast at Shetkari Bhavan. So please note these things. So before ending the session, I would like to extend my sincere thanks to Speaker Rahul Nigamji, scientist, ISRO, Ahmedabad, and reporters, Sunita Pawarman from session first. I would like to also thanks to Dr. Raghu Mukhugudeji, University of Florida, scientist, USA and IIT Bombay, and reporter Dr. Megha Jagtap Madam for session second. I would also like to thanks my sincere thanks to Speaker Pinam Chinnaswamiji and Dr. Godavari Pawar Madam as a reporter from session 3. I would also like to thank